For most of human history, the most dangerous moment of the day was not the hunt and not the journey across open land. It was the quiet moment when the fire burned low and the body had to close its eyes. Sleep is necessary for the brain to survive, yet sleep also makes every human slower to react, slower to see, and slower to escape danger. For thousands of generations, people had to enter this vulnerable state in a world filled with darkness, predators, and uncertainty. The human body still carries traces of that past in the way it wakes at small sounds in the night. If sleep is essential for life, but sleep once meant vulnerability, a simple question quietly appears. Why did 90% of human history sleep in fear? Long before cities, walls, or doors existed, every human body carried the same quiet requirement that it carries today. The brain cannot remain awake forever. After a certain number of hours, attention begins to fade, memory becomes unstable, and the systems that regulate emotion and perception begin to weaken. Sleep is not optional. It is a biological process deeply built into the nervous system of mammals. During sleep, the brain reorganizes information, clears metabolic waste, and restores the balance of neural activity that allows clear thinking during the following day. In modern life, this process often appears gentle and predictable. Night comes, lights dim, and people lie down in spaces designed for safety. But for the overwhelming majority of human history, the moment when the brain required sleep did not always arrive in a safe place. For early members of the human lineage, the world at night was rarely sealed off from the surrounding environment. Archaeological research suggests that much of early human life took place in open landscapes, temporary shelters, or shallow cave entrances rather than fully enclosed structures. These locations offered some protection from weather, but they did not create the kind of secure barrier that modern buildings provide. When darkness spread across these environments, visibility dropped quickly. Without artificial light, the night sky could illuminate only a small portion of the ground. Shadows moved with the wind, branches shifted, and unfamiliar sounds carried across long distances in the cooler air. In these conditions, the human brain faced a difficult evolutionary situation. On one hand, sleep remained necessary for survival because the body cannot maintain its systems without periods of rest. On the other hand, sleep reduced the ability to respond to changes in the environment. Reaction time slows, muscles relax, awareness narrows. The senses remain active, but they operate at a lower intensity. From the perspective of survival, this creates a biological tension that every sleeping animal must manage. Many species evolved strategies to reduce this risk. Some animals sleep in short bursts. Others sleep while partially maintaining awareness in one hemisphere of the brain. Some gather in groups where different individuals rest at different times. Humans did not evolve the ability to sleep with one half of the brain fully awake in the way certain marine mammals do. Instead, the human solution appears to have developed through social behavior and light sleep patterns that allow rapid waking when something unusual occurs. Even today, the sleeping brain remains sensitive to sudden changes in sound. A quiet environment may allow deeper sleep, but an unexpected noise can quickly trigger awakening. This pattern suggests that the human nervous system never fully abandoned its need to monitor the environment during rest. When scientists study sleep in modern laboratories, they often observe cycles in which the brain moves through lighter and deeper phases of sleep across the night. In lighter stages, the brain remains easier to awaken. This structure may reflect a balance shaped over thousands of generations in environments where total unconsciousness could carry risk. Early humans likely slept while the surrounding world continued to move. Wind passed through grasses, nocturnal animals searched for food, and distant calls traveled across the landscape. Under these conditions, sleep was never completely separate from the environment. It existed within it. The human body had to rest while still remaining connected to the sounds and rhythms of the night. That tension between rest and awareness forms one of the oldest patterns in the history of our species, a pattern that may help explain why the human mind still treats the night with a quiet caution that daylight rarely requires. The need for sleep did not begin with humans. It reaches far back into the evolutionary history of animals with nervous systems. Mammals, birds, and many other species all show forms of sleep that allow the brain to maintain its internal balance. Scientists studying these patterns often observe similar cycles across species, periods of reduced movement, lowered responsiveness, and shifts in brain activity that help regulate memory and learning. The human brain follows this same ancient pattern. Each night it moves through rhythms that repeat again and again, gradually restoring the systems that support attention, coordination, and emotional stability. Without these cycles, the brain becomes disorganized. Experiments in sleep deprivation show that memory weakens, reaction time slows, and perception becomes unreliable. From a biological perspective, sleep is not a luxury. It is part of the maintenance system of the brain itself. Yet, this necessary process introduces a problem that evolution could never completely remove. When a body sleeps, it becomes less capable of immediate response. Eyes close, muscles loosen. The mind drifts away from the surrounding environment. For animals living in open ecosystems, this creates a moment of vulnerability that cannot easily be avoided. Evolution has tried to solve this tension in many different ways. Grazing animals often sleep in short intervals, so that members of the herd remain alert while others rest. Some birds can maintain partial awareness during flight or while floating on water. Marine mammals such as dolphins can allow one hemisphere of the brain to sleep while the other remains active, enabling them to surface for air and monitor movement in the water. These strategies show how strongly natural selection favors systems that protect animals during sleep. The human lineage developed under very different conditions. Early humans were not equipped with specialized biological mechanisms that allowed sleep to occur without some loss of awareness. Instead, our ancestors relied on a combination of lighter sleep phases and social cooperation. Anthropological observations of traditional small-scale societies suggest that people often sleep near one another, creating a pattern where individuals naturally wake and shift position at different times during the night. Even when everyone is resting, the group rarely enters a state where all individuals are completely unconscious at the same moment. This pattern does not require organized planning. It emerges from the normal variations in human sleep cycles. When one person turns, coughs, or briefly wakes, the surrounding sleepers remain partly aware of those changes. The group environment becomes a kind of shared sensory system that extends beyond a single individual. Archaeological evidence cannot show exactly how prehistoric people slept on any specific night. However, it can reveal the types of environments in which sleep took place. Many early sites indicate temporary camps rather than permanent shelters. Stone tools, food remains, and traces of hearths often appear in open-air locations or shallow rock shelters. These spaces offered some protection from wind and rain, but rarely formed a sealed boundary between the sleepers and the outside world. The night air could still carry distant sounds. Animals could still move nearby. Darkness itself remained largely unbroken except for the light of a fire or the glow of the moon. In such surroundings, sleep would have unfolded within a landscape that remained active through the night. The human brain did not evolve in silent bedrooms or closed buildings. It evolved in environments where listening during sleep could matter. This may help explain why the human auditory system continues to monitor sound even when the body rests. A small noise in the dark can still awaken a person almost instantly, as if some deeper layer of the mind continues to keep watch while consciousness fades. Over thousands of generations, this delicate balance between rest and awareness likely shaped how humans experienced the night. The body had to sleep, but the mind could never fully forget the surrounding world. Across the long history of our species, sleep was never separated from the surrounding landscape. The human brain developed in environments where the boundary between rest and awareness remained thin. When darkness arrived, the world did not stop moving. Nocturnal animals continued their routines, winds shifted through vegetation, and the temperature of the air slowly dropped. Early human groups could not fully isolate themselves from these changes. Their bodies needed sleep, but the environment remained active around them. This created a condition in which sleep had to coexist with uncertainty. The structure of human sleep still reflects this tension. Modern sleep research shows that the night is not a single continuous state of deep unconsciousness. Instead, the brain moves through repeating cycles that include both lighter and deeper stages. During lighter stages, the sleeper can awaken relatively easily. Even subtle changes in sound or movement may trigger a return to wakefulness. Deeper stages follow, allowing the brain to perform the restoration processes that support learning, memory consolidation, and emotional balance. but these deeper phases do not last indefinitely. The brain repeatedly rises back toward lighter sleep before descending again. This rhythm creates multiple moments across the night when a person can respond quickly to the environment if necessary. From an evolutionary perspective, this pattern may represent a compromise between two competing needs. The body requires periods of deep restoration, yet complete disconnection from the surroundings could be dangerous in an open ecosystem. By alternating between deeper and lighter sleep, the brain maintains the ability to wake if the environment suddenly changes. Evidence from anthropology supports the idea that human sleep often developed in social and environmental contexts where such responsiveness mattered. Observations of contemporary hunter-gatherer communities, while not identical to prehistoric life, suggest that sleeping areas are usually arranged so that individuals remain close enough to hear one another. In these groups, sleep rarely occurs in perfectly synchronized patterns. Some people fall asleep earlier, others later. Some wake briefly during the night and then return to sleep. When researchers study these patterns, they often find that at almost any moment during the night, at least one person in the group is awake or shifting in lighter sleep. This natural staggering of sleep cycles may have helped reduce the risks associated with nighttime vulnerability without requiring formal organization or assigned roles. Archaeological findings also hint at environments where sleep remained connected to the outside world. Hearths, stone tools, and food remains often appear in sites that were used repeatedly but not permanently occupied. These places suggest temporary camps rather than long-term buildings. Even in caves, many sleeping areas were positioned near entrances where smoke could escape and fresh air could circulate. Such locations offered shelter, yet they still allowed the sounds and smells of the surrounding landscape to reach those inside. The night, in other words, was never completely shut out. This context matters when considering how human perception developed. The brain systems that regulate sleep evolved within conditions where silence and isolation were rare. Instead, the mind learned to rest while faint signals from the environment continued to pass through the senses. A distant animal call, the crackle of a fire, or the shifting of another sleeper nearby could all become part of the background awareness that accompanies human rest. Over many generations, the nervous system adapted to maintain this partial sensitivity. Even today, the sleeping brain filters sounds in a way that allows familiar noises to fade into the background while unusual ones stand out. A person may sleep through the steady hum of wind, but wake quickly at an unexpected footstep. This ability reflects an ancient balance that shaped human sleep from the beginning. The body must surrender to rest, yet the mind never entirely abandons the night that surrounds it. When the sun disappears beyond the horizon, the world changes in ways that are easy to forget in modern life. Artificial lighting now stretches the day far beyond its natural limits, but for most of human history, night arrived suddenly and completely. Without electric light, the transition from day to darkness could take only a short time. As the last light faded, the landscape lost its detail. Colors disappeared first, then shapes softened, and finally even familiar paths became difficult to recognize. The human eye is capable of adjusting to low light, yet it remains far less effective in darkness than the eyes of many nocturnal animals. This difference has deep evolutionary roots. Humans evolved primarily as daytime foragers and hunters. Our vision depends heavily on color and fine detail, traits that work best under sunlight. At night, these advantages weaken. The retina relies more on cells that detect motion and faint light rather than precise shapes. As a result, the world becomes less predictable once darkness settles across the land. In prehistoric environments, this change affected nearly every aspect of survival. During the day, early human groups could scan the horizon, track movement through vegetation, and navigate familiar terrain. The sun provided a reliable source of orientation and visibility. Night removed much of that information. Even landscapes that were well known in daylight could feel unfamiliar after sunset. Small sounds traveled farther through the cooler night air, and shadows could shift with wind or moonlight in ways that made them difficult to interpret. In such conditions, uncertainty became part of the nighttime environment. Archaeological evidence suggests that early humans often lived in regions where darkness was profound. Away from modern cities, the night sky can become extraordinarily dark once the moon sets or clouds cover the stars. Without artificial illumination, even large objects may fade into near invisibility beyond a short distance. This means that for much of human history, people entering the night were stepping into a sensory world that offered far less visual information than the day. Movement could still occur around them, but it might not be seen until it was very close. This sensory imbalance shaped how the human body experienced the night. Hearing became more important once sight weakened. Many people today notice that quiet sounds seem louder after dark. This is not only because the environment grows quieter, but also because attention shifts toward listening when vision provides less guidance. Early humans likely relied heavily on these auditory cues while resting. The rustling of leaves, distant animal calls, or the movement of another person in the group could all provide information about the surrounding world. The brain remains sensitive to such signals even during sleep. Temperature also played a role in shaping nighttime experience. In many prehistoric regions, air temperatures dropped noticeably after sunset. Cooler air can carry sound more efficiently across distance, which may have made nighttime noises travel farther than during the day. At the same time, the cold encouraged early humans to gather closer together or remain near sources of warmth. This created social spaces where sleep occurred in shared proximity rather than isolation. Darkness, cooler air, and the limits of human vision combined to produce a landscape that behaved differently after sunset. Daytime knowledge did not disappear entirely, but it became harder to apply when familiar features faded into shadow. Early humans entering the night could not rely on the same senses that guided them through daylight hours. Instead, they experienced a world where listening mattered more than seeing, where movement could be heard before it was visible, and where the boundary between known and unknown space became less certain. In such conditions, the approach of sleep did not occur in a perfectly calm environment. The body prepared for rest, yet the surrounding world remained active and partially hidden by darkness. The human nervous system had to adapt to this reality, learning to sleep within a night that could never be fully observed. As darkness settled across prehistoric landscapes, the change was not only visual. The entire atmosphere of the environment shifted in ways that shaped how humans experienced the night. During daylight hours, sunlight warms the ground and lifts rising air currents into the sky. These currents carry sounds upward and disperse them across the landscape. When evening arrives, that pattern reverses. The air near the ground cools and becomes more stable, allowing sound to travel farther and more clearly through the stillness of the night. This quiet amplification of distant noises likely played an important role in how early humans interpreted the darkness around them. A rustle that might be unnoticed during the busy hours of the day could become strikingly clear after sunset. A branch snapping somewhere beyond the edge of a camp might echo through the cooler air. Even the movement of animals far away could reach human ears when the night grew calm. In a world without mechanical noise, these sounds would stand out sharply against the silence. The human brain is highly sensitive to unexpected auditory signals, especially when visual information is limited. When sight becomes unreliable, hearing naturally takes a larger role in interpreting the surroundings. This shift in sensory attention may have influenced how early humans experienced the moments before sleep. As night deepened, listening became an important part of awareness. Sounds could reveal whether the environment remained calm or whether something unfamiliar was moving nearby. Anthropologists studying traditional communities that live close to natural environments often observe how carefully people attend to nighttime sounds. The calls of certain animals may indicate the presence of predators, changes in weather, or movement through the surrounding landscape. These patterns are not always interpreted consciously. Instead, the brain gradually learns which sounds belong to the normal rhythm of the night and which signals might require attention. Such sensitivity likely developed over many generations of human life in environments where sound carried important information after dark. Darkness also altered the spatial experience of the landscape. During the day, distance can often be judged through visual cues such as color contrast, shadows, and the outlines of objects. At night, many of these signals disappear. Without strong light, depth becomes harder to judge. A nearby bush may appear similar to a distant tree, and movement in the darkness can be difficult to place accurately. This uncertainty changes how the human mind interprets space. Instead of relying on sight, people must rely more on memory and sound to understand what surrounds them. The mind begins to reconstruct the landscape using fragments of information gathered during the day and subtle cues gathered during the night. The moon and stars sometimes provided partial illumination, but their effect varied widely. A bright full moon could reveal shapes across open terrain, yet dense clouds or thick forest could erase nearly all visible detail. In many regions where early humans lived, the lunar cycle meant that several nights each month became especially dark. During these periods, visibility could shrink dramatically. People resting in open camps or near rock shelters would have been aware that the surrounding landscape remained largely unseen. This condition did not necessarily mean that danger was present, but it did mean that certainty was limited. The human mind tends to respond carefully in situations where information is incomplete. In evolutionary terms, responding cautiously to uncertain signals may have been safer than ignoring them entirely. Over long stretches of human history, the combination of deeper darkness, amplified sound, and uncertain distance created a nighttime environment that differed greatly from the predictable clarity of day. When early humans lay down to sleep within this setting, the body entered rest while the surrounding landscape continued its quiet activity. The senses, particularly hearing, remained connected to that environment. Even as the mind drifted toward sleep, it remained partly tuned to the sounds of the night that stretched beyond the edge of the firelight. As the night deepened in prehistoric landscapes, the world did not simply become darker, it became different. The rhythm of activity across the environment shifted from the patterns of the day to those of the night. Many animals that remained hidden during daylight began to move once the sun disappeared. Small mammals emerged from burrows, insects filled the air with faint vibration, and nocturnal hunters started their search for food. For early human groups resting on the ground or inside shallow shelters, this meant that the surrounding ecosystem remained active long after the day had ended. In daylight, movement across the land could usually be seen from a distance. A herd crossing an open plain or a predator moving along a ridge would often reveal itself through visible motion. At night, that balance changed. Many animals that navigate well in darkness rely less on sight and more on smell, hearing, or low-light vision. Humans, by contrast, remained visually limited in the dark. This difference created a quiet asymmetry between humans and other creatures of the night. While humans could still hear and sense their surroundings, they could rarely observe the full range of activity occurring beyond the edge of their immediate space. The archaeological record cannot show every moment of prehistoric nights, but ecological knowledge helps reconstruct the types of environments early humans inhabited. Many of these environments contained species that were naturally active after sunset. Large predators such as lions and leopards in Africa, or wolves and other carnivores in Eurasia, often hunt during cooler hours of the night. Smaller animals also increase their movement during darkness when daytime predators are less active. These patterns mean that nighttime ecosystems can sometimes contain more hidden motion than the same landscape during the day. For a human resting within such an environment, most of that activity would remain invisible. Yet the signs of it could still be heard. Footsteps through dry grass, the shifting of branches, or distant animal calls could reach the ears of sleepers even when the source could not be clearly identified. The human mind is naturally attentive to uncertain signals like these. A sound that cannot immediately be explained often draws more attention than one that is familiar. Over long periods of evolution, responding cautiously to unclear signals may have helped reduce risk in environments where unseen movements sometimes mattered. This does not mean that danger was constant every night, but it does suggest that the human brain developed in settings where the night could never be completely interpreted through sight alone. Fire may have offered a small island of visibility within this darkness. Archaeological evidence shows that hearths appear regularly in many prehistoric sites, suggesting that controlled fire was an important part of human life. The glow of a fire provided warmth and light, but its reach remained limited. Beyond a short circle, darkness returned quickly. Within that circle, shadows flickered as flames moved, and wind passed through the camp. The fire created a boundary between a small, illuminated space and the larger night that surrounded it. Those resting near the warmth of the fire could see one another and hear the quiet sounds of their group, yet the wider landscape continued beyond the edge of the light. In that sense, prehistoric sleep often occurred within a narrow zone of familiarity, set inside a much larger environment that remained unseen. The human body could relax beside the warmth of the fire and the presence of companions, but the senses never fully detached from the surrounding world. Hearing remained active, and even slight changes in sound could travel through the night air toward the resting group. Over thousands of generations, this relationship between sleep and environment shaped how the human nervous system learned to rest. The body required sleep, yet the night beyond the firelight continued to move with its own quiet life, reminding the sleeping mind that darkness was never completely empty. For early humans, the night was not only darker than the day, it was also the time when many powerful animals became active. Across the landscapes where human evolution unfolded, ecosystems included predators that moved most effectively during the cooler hours after sunset. Large carnivores such as lions, leopards, hyenas, and other hunters often relied on darkness to approach prey more quietly. Their senses were adapted to conditions that limited human vision. Many possessed stronger night vision, heightened hearing, or an acute sense of smell that allowed them to navigate environments that humans could barely observe. This difference did not mean that humans were constantly hunted, but it did mean that people living within these ecosystems shared the night with animals whose abilities in darkness were far greater than their own. Ecological studies of modern predator behavior help illustrate how these patterns work. Many large carnivores avoid the intense heat of the day and instead become more active at dusk or during the night. Cooler air allows them to move longer distances without overheating, and darkness can help conceal their approach. These advantages shape the rhythm of the landscape. While daylight often belongs to animals that depend on vision and open movement, nighttime activity shifts towards species that rely on stealth and sensory awareness. Humans, whose bodies evolved primarily for daytime activity, occupy a different position within this rhythm. Our eyes can adjust to dim light, but they cannot match the sensitivity of animals built for nocturnal hunting. In prehistoric environments, this difference likely influenced how early humans organized their resting places. Archaeological evidence suggests that human camps were often located in positions that provided at least some natural protection. Rock shelters, elevated ground, or areas near cliffs sometimes appear repeatedly in prehistoric sites. These locations may have offered advantages such as improved visibility during daylight or reduced access for large animals approaching from certain directions. Even so, such places could not completely isolate human groups from the surrounding ecosystem. The night still belonged to many creatures whose lives continued while humans rested. Fossil and ecological records show that the regions where early humans lived supported a wide variety of carnivorous species. In Africa, for example, several large predators have shared the landscape with human ancestors for hundreds of thousands of years. In Eurasia, wolves and other carnivores occupied similar ecological roles. These animals were not always in direct conflict with humans, yet their presence shaped the environment in which humans slept. Awareness of large animals moving across the landscape may have influenced how human groups gathered, where they placed their fires, and how closely they remained together during the night. Anthropological research suggests that many traditional societies still recognize the importance of group proximity when resting outdoors. Sleeping near others provides a form of shared awareness. Even if most members of a group are asleep, the collective presence of many bodies can create subtle layers of detection. One person may stir in response to a sound that others did not notice, and that small movement may in turn alert someone nearby. Over time, such patterns could reduce the likelihood that a group would remain unaware of unusual activity in the surrounding environment. The presence of predators also influenced how animals behave toward one another within ecosystems. Many herbivores adjust their movements depending on where predators are likely to appear. This creates a landscape of shifting activity, where different species move at different times to balance feeding opportunities with safety. Humans living within these systems would have been part of that same ecological network. Although human intelligence, cooperation, and the use of tools eventually gave our species strong advantages, those developments did not remove the basic reality that humans once slept in environments shared with powerful animals. The night air carried the sounds of those ecosystems, distant calls, movement through vegetation, and occasional signals that something unseen was passing through the darkness. For people resting beside a fading fire, these sounds formed part of the larger world that continued beyond the limits of human sight. Sleep had to occur within that living landscape, where the presence of other species remained a quiet but constant part of the night. Across prehistoric ecosystems, predators did not move randomly through the landscape. Their behavior followed patterns shaped by energy, temperature, and opportunity. Large carnivores often conserved their strength during the hottest hours of the day and became more active when the air cooled after sunset. This shift allowed them to travel farther while expending less energy, and it also placed them in an environment where many prey animals were resting or less alert. Darkness, in this sense, became part of the natural hunting strategy of many species. Humans shared these same environments, but their bodies were not designed for efficient movement in darkness. The human eye performs best under daylight conditions where color, contrast, and fine detail are visible. When light fades, these abilities decline rapidly. Other animals compensate with eyes adapted to low light or with sensory systems that detect movement in ways humans cannot easily match. This difference created an uneven balance between humans and certain nocturnal hunters. Even when people were not the intended prey of these animals, the presence of large carnivores in the environment could influence how human groups behaved during the night. Ecologists studying modern wildlife often describe landscapes as networks of overlapping territories. Different species move through the same terrain but follow their own schedules of activity. Some animals forage during daylight, others at dusk, and many during the night. These rhythms reduce competition and help maintain balance within the ecosystem. For early humans living within such systems, nighttime activity in the surrounding environment would not have stopped simply because people were sleeping. Instead, the night belonged to a different set of movements and sounds that continued across the land. Archaeological evidence occasionally reveals traces of these interactions between humans and predators. Bones bearing tooth marks, animal remains near human camps, and patterns of site selection suggest that human groups were aware of the presence of large carnivores in their surroundings. These findings do not indicate constant conflict, but they do show that humans and predators occupied the same ecological spaces. In some cases, predators may even have been attracted to the remains of food left behind by human camps. This possibility may have encouraged early humans to manage their sleeping areas carefully, keeping fires burning or choosing locations where approaching animals would be easier to detect. Anthropologists studying present-day hunter-gatherer groups sometimes observe similar strategies. Camps are often arranged in ways that keep sleeping individuals close together, while leaving space around the group where movement can be noticed. Fires may be maintained through the night, not only for warmth but also for visibility and the psychological boundary created by light. The glow of a fire does not completely prevent animals from approaching, yet many species avoid bright flames and sudden movement. The fire becomes both a physical and symbolic center of the camp, marking a place where humans gather while the wider darkness remains beyond its reach. The presence of predators in prehistoric environments also shaped the awareness of other animals. Herd animals often react strongly to unexpected movement or unfamiliar sounds, and these reactions can ripple through the ecosystem. A sudden alarm call from one species may signal danger to others nearby. Humans listening from a resting place might have heard such signals even when they could not see the cause. In this way, the sounds of other animals sometimes provided indirect information about what was happening beyond the limits of firelight. Over time, living within these ecosystems required humans to develop a careful relationship with the night. Sleep still arrived because the body demanded it, but the surrounding environment remained active with creatures whose senses worked differently in darkness. The human mind did not need to assume that every sound meant danger, yet it learned that the night contained movement beyond what could easily be seen. Rest therefore unfolded in a landscape shared with other living beings, whose lives continued through the hours when humans closed their eyes. Within ecosystems shared by humans and large carnivores, the relationship between species was rarely simple. Predators did not spend their time searching specifically for humans, and human groups were not defenseless participants within these landscapes. Early humans possessed advantages of their own, including cooperation, tool use, and the ability to communicate complex signals within a group. Over many generations, these abilities helped people navigate environments that included powerful animals. Even so, the presence of predators shaped the atmosphere of the night in ways that could not easily be ignored. Most large carnivores rely on caution when approaching unfamiliar situations. A group of humans gathered together, speaking, moving, and maintaining a fire would not appear the same as a solitary animal resting in open terrain. Firelight, shifting shadows, and the scent of smoke could all signal that something unusual was present. For this reason, predators often avoid human camps when they clearly recognize human activity. Yet the boundary between safety and uncertainty remained delicate. The effectiveness of human defenses depended on conditions such as visibility, the number of people present, and whether the fire remained strong through the night. If flames weakened or the group became quiet, the surrounding darkness once again expanded toward the sleeping area. Archaeological sites frequently contain hearths that appear repeatedly in the same locations, suggesting that fire was maintained regularly when humans occupied these spaces. The presence of burned stone, charcoal, and ash layers indicates that fires were an important part of daily life. Their warmth made colder nights more comfortable, but their light may also have helped create a visible center around which people gathered. Firelight can illuminate nearby ground and reveal movement within a short distance, yet beyond that circle, darkness quickly returns. In this way, fire formed a boundary between the known space of the group and the larger environment that remained unseen. Human awareness often focused on that boundary. Any sound approaching from the darkness could draw attention, particularly if it did not match the familiar rhythm of the camp. Anthropologists sometimes describe this type of awareness as environmental listening, a state in which people remain quietly attentive to the background sounds of their surroundings. This form of listening does not require constant fear. Instead, it reflects an understanding that information about the environment may arrive through subtle signals. A sudden silence among insects, the movement of animals through vegetation, or the change in direction of a distant call can all indicate that something unusual is occurring. For early humans resting in open camps or shallow shelters, such signals may have carried meaning even when the source could not be clearly seen. The human brain is particularly sensitive to irregular patterns in sound. Neuroscientists studying sleep often observe that the brain continues to monitor auditory information even when consciousness fades. Familiar, repetitive noises may be filtered out, allowing deeper sleep, but unexpected sounds can quickly trigger awakening. This sensitivity likely reflects a long evolutionary history in which hearing remained a useful source of information during rest. The ability to wake rapidly when something unusual occurred would have helped individuals respond to changes in the environment without remaining awake throughout the entire night. Over time, these biological and behavioral patterns shaped the way humans experienced darkness. Night was not necessarily filled with constant danger, yet it was rarely empty of life. Predators moved through their territories, smaller animals searched for food, and the environment produced a steady flow of sounds that traveled through the cooler air. Within this living landscape, human groups gathered close to one another and allowed sleep to arrive gradually. The body needed rest, but the senses never completely withdrew from the world beyond the firelight. In this balance between sleep and awareness, the night remained both a place of recovery and a reminder that the wider ecosystem continued its quiet movement long after human eyes had closed. Sleep changes the human body in ways that are both necessary and fragile. When a person begins to fall asleep, the nervous system gradually shifts away from the alert state that guides movement and attention during the day. Muscles loosen, breathing becomes slower, and the brain begins to reduce the constant stream of signals that normally interpret the outside world. This transition allows the body to conserve energy and perform internal maintenance that cannot occur while fully awake. Yet the same changes that support recovery also reduce the body's ability to respond quickly to sudden events. In daylight hours, human perception depends on a coordinated network of senses and rapid motor responses. Eyes scan the environment, ears track changes in sound, and muscles remain prepared for movement if something unexpected occurs. When sleep arrives, this system becomes quieter, reaction time slows, and the connection between perception and movement weakens. The brain continues to process information, but it does so at a lower intensity. For a species that evolved in open environments, this shift creates a delicate biological moment. The body must enter sleep to survive, yet sleep temporarily reduces the speed at which a person can react to the surrounding world. Modern sleep studies reveal how deeply this change affects the brain. During the early stages of sleep, neural activity begins to move away from the fast patterns seen during wakefulness. Brain waves slow and synchronize, reflecting a state in which attention turns inward rather than outward. As sleep deepens, sensory signals from the outside world are filtered more strongly by the thalamus, a structure that acts as a gateway between the senses and the cortex. Many external stimuli no longer reach full conscious awareness. This filtering protects the sleeping brain from constant interruption, allowing deeper restorative processes to take place. However, the filter is not absolute. Certain sounds or movements can still break through and trigger awakening, especially if they are sudden or unfamiliar. This partial filtering may represent a compromise shaped over long evolutionary time. If the brain ignored every external signal during sleep, a person might remain unconscious even when the environment changed in important ways. If the brain responded to every small noise, deep sleep would rarely occur. Human sleep therefore balances between these two extremes. The mind becomes quieter and less responsive, but it does not completely detach from the environment. The body also enters a state of reduced mobility during deeper stages of sleep. Muscles relax to prevent the body from physically acting out dreams, a mechanism that helps protect the sleeper from injury. While this relaxation is beneficial, it also means that immediate movement becomes more difficult. If someone is suddenly awakened from deep sleep, it may take several moments for full coordination to return. This delay illustrates how strongly the sleeping state alters the body's normal readiness for action. For early humans resting in environments that were not fully enclosed, this vulnerability would have been part of the natural rhythm of life. Sleep could not be postponed indefinitely. Eventually, the brain required rest, even if the surroundings were imperfectly secure. The human solution was not to eliminate vulnerability, but to manage it through patterns of sleep that allowed periodic awareness and rapid waking when necessary. Over thousands of generations, the body and brain adapted to operate within this balance. The nervous system learned to descend gradually into deeper sleep and then return repeatedly toward lighter stages across the night. In this way, rest and awareness continued to alternate, even while the body lay still. This biological rhythm reflects a simple truth about the human condition. Sleep restores the mind, but it also reminds us that the body cannot remain alert forever. Every night, humans must surrender part of their awareness to regain their strength, even when the world beyond the darkness continues to move. As sleep deepens, the human body moves further away from the alert state that supports survival during the day. The senses do not disappear, but their connection to conscious awareness becomes weaker. Light passing through closed eyelids is faint, shapes dissolve into darkness, and visual interpretation largely pauses. Hearing continues to function, yet the brain treats many sounds as background noise unless they are sudden or unusual. Touch remains present through the contact between the body and the ground, the warmth of nearby companions, or the subtle movement of air across the skin. Even so, the overall state of the body shifts towards stillness. This stillness is not simply a matter of comfort. It is a biological condition carefully regulated by the nervous system. During deeper stages of sleep, the brain releases signals that reduce muscle activity throughout the body. This process helps prevent sleepers from physically acting out dreams. It also allows muscles to relax after the work of the day. From the perspective of recovery, this relaxation is beneficial. Yet it also illustrates why sleep creates a vulnerable moment. A body that is deeply relaxed cannot respond instantly in the same way a waking body can. If a sudden stimulus occurs, the brain must first transition back toward wakefulness before coordinated movement becomes possible. Sleep researchers often describe this transition as a process rather than a switch. Awakening takes time, sometimes only a few seconds, but those seconds reflect a rapid reorganization inside the brain. Neural circuits that regulate attention, balance, and movement must become active again. Blood flow increases in regions responsible for decision-making and perception. The body gradually regains its ability to interpret signals from the outside world and translate them into action. For people living in environments designed for safety, this brief delay rarely matters. A bedroom door, a stable building, and the absence of large animals nearby reduce the urgency of immediate response. For most of human history, however, sleep did not occur within such controlled spaces. Early humans often rested in environments that remained partly open to the surrounding landscape. Rock shelters, temporary camps, and natural clearings offered protection from weather, but they did not isolate sleepers completely from the outside world. In these settings, the difference between wakefulness and sleep carried practical significance. A person who woke quickly could observe a change in the environment sooner than someone who remained deeply asleep. This does not mean that people lived in constant alarm. The human brain cannot remain in a permanent state of fear and still maintain health. Instead, the nervous system developed patterns that allowed sleep to proceed while preserving the ability to return to awareness when necessary. One of these patterns appears in the structure of sleep cycles themselves. Throughout the night, the brain repeatedly shifts between lighter and deeper phases of rest. Lighter phases occur regularly, providing moments when awakening becomes easier. During these periods, even a small disturbance may bring a person briefly back to consciousness before sleep resumes. Anthropologists studying sleep in traditional societies sometimes observe these short awakenings across the night. Individuals may stir, adjust their position, or briefly look around before returning to rest. These moments are not always remembered the next morning, yet they represent a natural rhythm within human sleep. The body does not remain locked in a single depth of rest. Instead, it moves gradually through stages that alternate between deeper recovery and lighter awareness. Within prehistoric environments, such patterns may have helped maintain a subtle connection between sleepers and their surroundings. If a sound or movement occurred nearby, someone in the group might already be near the edge of wakefulness. That individual could respond more quickly, shifting attention toward the environment before the rest of the group fully awakened. In this way, the biology of human sleep may have supported survival not by eliminating vulnerability, but by ensuring that vulnerability was rarely complete or uninterrupted throughout the entire night. Even when the human body appears completely still during sleep, the brain continues to operate through complex internal rhythms. These rhythms move in cycles that repeat across the night, gradually guiding the sleeper through changing levels of awareness. Some phases allow deep restoration, while others bring the mind closer to wakefulness. This shifting pattern means that sleep is rarely a uniform state. Instead, it is a sequence of changing conditions that shape how the brain responds to the environment while the body rests. One of the most important aspects of this system is the way the brain regulates incoming sensory information. While awake, the brain continuously processes signals from sight, sound, touch, and movement. During sleep, many of these signals are filtered before reaching full awareness. Structures deep within the brain help manage this process, allowing repetitive or familiar sensations to fade into the background while leaving open the possibility that unusual stimuli can still be detected. This filtering allows sleep to remain stable without disconnecting the sleeper completely from the outside world. The brain therefore maintains a delicate balance. It protects the restorative processes of sleep while preserving the capacity to respond when something unexpected occurs. This balance becomes particularly important when considering the environments in which early humans slept. Unlike modern homes, prehistoric sleeping places rarely created total separation from the surrounding landscape. Sounds from the environment could travel freely into camps or rock shelters. The crackling of firewood, the movement of wind through vegetation, and the calls of animals formed a background layer of sound that the brain gradually learned to interpret as normal. Over time, familiar patterns became part of the expected rhythm of the night. When these patterns remained steady, the brain could allow deeper sleep to continue. When they changed suddenly, attention could return quickly. Neuroscientists studying sleeping brains often observe this sensitivity through the way certain sounds trigger rapid awakening. A sharp noise, an unfamiliar voice, or a sudden disturbance can activate alert systems even during deeper stages of rest. The sleeper may not remember the exact moment of awakening, yet the body responds by increasing heart rate, shifting posture, or opening the eyes. These reactions occur because the brain maintains pathways that remain capable of detecting significant changes in the environment. This system likely developed through long evolutionary experience in settings where environmental signals carried meaning. Another important element of sleep involves the body's internal clock. Human physiology follows daily rhythms that align roughly with the cycle of daylight and darkness. As evening approaches, the brain releases signals that encourage sleepiness, gradually preparing the body to rest. These rhythms evolved in coordination with natural light patterns that shaped the daily activities of early humans. Once darkness arrived, most practical tasks became difficult to perform without artificial light. Sleep therefore became the natural way for the body to pass through the longest hours of night. Yet even as sleep settled over the body, the surrounding environment remained active. Animals continued to move, wind shifted across the land, and distant sounds traveled through the cooler air. The human brain adapted to this reality by maintaining a form of partial environmental awareness that coexisted with sleep itself. Instead of completely abandoning the outside world, the mind rested while still monitoring faint signals from the environment. This arrangement allowed the body to recover while preserving the ability to awaken if something unusual occurred nearby. Over thousands of generations, such patterns likely shaped the character of human sleep. Rest was necessary, but it unfolded within a living world that never entirely fell silent. The night continued its quiet activity beyond the edge of human awareness, and the sleeping brain remained gently connected to that distant movement through senses that never fully turned away from the dark. For much of human history, sleep was rarely an individual activity. Instead of resting alone in separate spaces, people often slept close to one another. This pattern appears repeatedly in anthropological observations of small-scale societies and is also consistent with what archaeologists infer from prehistoric camps. The physical arrangement of sleeping places suggests that early humans gathered together at night rather than spreading out across the landscape. In environments where the night remained uncertain, proximity offered advantages that went beyond simple comfort. When several individuals rest near one another, their senses combine into a shared system of awareness. A single person sleeping alone can miss subtle changes in the environment, but a group of sleepers naturally creates multiple points of perception. Each individual enters sleep at a slightly different time and moves through sleep cycles at a slightly different pace. These small differences produce a pattern in which the group rarely reaches the same depth of sleep simultaneously. Some people drift into deeper rest, while others remain in lighter stages or briefly awaken. The result is not a deliberate system of watchfulness, yet it functions in a similar way. At almost any moment during the night, someone may be close to waking, adjusting position, or responding to a sound that others have not noticed. Anthropologists studying sleep patterns in traditional hunter-gatherer groups have documented this natural staggering of sleep cycles. In many cases, researchers observe that individuals within the group wake and sleep at different times throughout the night. Some awaken briefly to adjust a blanket or feed a fire, while others remain asleep. Over the course of the night, these short awakenings spread across the group in a way that ensures that complete silence and stillness rarely occur all at once. Even without planned coordination, the group maintains a subtle continuity of awareness. From an evolutionary perspective, such patterns may have helped reduce the risks associated with sleeping in open environments. If one person noticed an unusual sound, the movement or voice of that individual could alert others nearby. A single moment of awareness could quickly ripple through the group, bringing several people back to wakefulness if needed. This system did not require constant vigilance. Instead, it relied on the natural rhythms of human sleep and the simple fact that people rested together. Archaeological evidence provides indirect support for this idea. Many prehistoric camps show signs of repeated use in areas where space was limited, suggesting that groups gathered closely around shared hearths or sheltered spots. The distribution of stone tools, animal bones, and hearth remains often indicates communal living spaces rather than widely separated sleeping areas. Although these traces cannot reveal exactly how individuals arranged themselves during sleep, they do suggest that nighttime life occurred within shared social spaces. Fire often formed the center of these spaces. The warmth and light of a hearth drew people together, creating a focal point around which activity gradually slowed as evening progressed. As the fire burned lower, members of the group might lie down nearby, keeping close enough to share warmth and conversation before sleep arrived. In such settings, the presence of others would have shaped the experience of night. Familiar breathing, quiet movements, and the soft crackle of firewood created a background of known sounds that distinguished the safety of the group from the unknown space beyond it. Within this circle of shared presence, sleep could unfold more easily. The human body still entered the vulnerable state required for rest, yet it did so within the awareness that other members of the group remained nearby. Over long stretches of human history, this habit of sleeping together may have helped transform the night from an entirely uncertain space into one where cooperation and proximity offered a measure of stability. The group did not eliminate the challenges of darkness, but it allowed individuals to rest while surrounded by the quiet signals of others who shared the same night. Sleeping close together did more than simply combine awareness among members of a group. It also changed the emotional experience of the night. Humans are a deeply social species, and many aspects of our behavior developed within the presence of others. The human brain responds strongly to signals of social safety, such as familiar voices, predictable movement, and the quiet rhythm of breathing from nearby companions. When these signals are present, the nervous system tends to relax more easily. In environments where the night carried uncertainty, the presence of others may have helped the body enter sleep despite the surrounding darkness. Anthropologists observing traditional societies often describe nighttime camps as social spaces that gradually transform as evening progresses. Conversations may continue for some time after the sun sets, and people often remain gathered around a shared fire. The glow of the flames provides light and warmth, but it also creates a visible center for the group. As the hours pass and fatigue grows, individuals slowly settle down near that central space. The transition from wakefulness to sleep does not happen all at once. Instead, it spreads gradually through the group as different people drift into rest at slightly different moments. This gradual pattern of sleep may have had practical advantages. When several people are awake at the beginning of the night, the environment can still be observed and discussed. Sounds or movements in the distance can be interpreted collectively, reducing uncertainty about what might be happening beyond the camp. As some individuals fall asleep, others remain alert for a time before eventually resting as well. Later in the night, those who wake briefly may notice the fading of the fire or the cooling of the air and adjust the camp accordingly. These small actions, repeated across generations, could help maintain a stable sleeping environment even without formal organization. The social structure of early human groups may also have influenced how sleep was arranged. Many anthropologists believe that prehistoric communities often included individuals of different ages sharing the same resting area. Adults, adolescents, and children would likely have remained close together rather than separating into distinct sleeping spaces. This arrangement allowed experienced members of the group to remain near younger individuals who required protection and care. In this context, sleep became not only a biological necessity but also part of the broader system of cooperation that supported group survival. Evidence from studies of modern hunter-gatherer societies suggests that children often sleep near parents or other relatives, a pattern that may reflect very old human traditions. Proximity allows adults to respond quickly if a child becomes restless or frightened during the night. It also ensures that the youngest members of the group remain within the circle of warmth and familiarity created by the camp. For adults, the presence of children may reinforce the importance of maintaining a calm and attentive environment during the night. Even brief awakenings could prompt quiet adjustments, such as feeding the fire or checking that everyone remained comfortable. Over time, these habits may have shaped how the human brain associates sleep with social presence. Many people today still find it easier to sleep when they sense that others are nearby, even if those others are resting quietly in the same home. The feeling of safety created by familiar human sounds appears to calm the nervous system in subtle ways. This response likely has deep evolutionary roots. For countless generations, humans rested not in isolation, but within groups whose shared presence reduced the uncertainty of the night. Within that social circle, the body could enter sleep while the mind remained gently aware that it was not alone in the darkness beyond the firelight. When people rest close together, the group does more than simply share warmth and awareness. It also creates a quiet network of signals that help regulate the rhythm of the night. Every sleeping person produces small movements, breathing patterns, and subtle sounds that become part of the background environment. These signals may seem insignificant on their own, yet together they form a stable pattern that the brain gradually learns to recognize as familiar. Within this shared environment, the human nervous system can relax more easily, because the surrounding sounds belong to known companions rather than the uncertain space beyond the camp. Researchers who study sleep often note that the brain becomes accustomed to regular patterns in the environment. Repetitive sounds such as breathing, gentle movement, or the soft crackling of a fire can fade into the background as the mind settles into rest. These sounds become part of the expected rhythm of the night. When the pattern remains stable, the brain allows deeper stages of sleep to unfold. When something interrupts that pattern, attention returns quickly. A sudden silence, an unfamiliar step, or an unexpected voice can draw immediate notice because it breaks the continuity of the environment the sleeper has learned to trust. Within early human groups, the presence of many individuals would have created a complex web of these familiar signals. The slow rise and fall of breathing, the shifting of bodies against the ground, and the quiet murmur of someone turning in sleep all contributed to a sense of continuity. These sounds did not eliminate the uncertainty of the night outside the group, but they formed a recognizable layer of human activity that distinguished the camp from the wider landscape. The brain could anchor itself to this familiar pattern while still remaining sensitive to changes that occurred beyond it. This arrangement may also explain why complete silence can sometimes feel unsettling in unfamiliar environments. When the brain expects a certain level of background activity and that activity disappears, attention sharpens. Many people notice that a quiet room in an unfamiliar place can make sleep more difficult, even when the environment is physically safe. The absence of familiar signals leaves the mind without the reference points it normally uses to judge stability. In prehistoric settings, the shared sounds of a group would have provided those reference points each night. The presence of others allowed individuals to relax into sleep while still remaining connected to the social environment around them. Over generations, this pattern of communal rest may have shaped how humans interpret nighttime sounds more broadly. A quiet rustle inside the group might be recognized as the movement of a companion, while a similar rustle beyond the edge of the camp could draw attention because it originated outside the familiar circle. In this way, the group itself acted as a boundary between known and unknown space. Inside that boundary were the predictable rhythms of human presence. Beyond it lay the larger ecosystem of animals, wind, and darkness that continued through the night. This distinction likely helped the human mind organize sensory information during sleep. The brain could allow familiar signals to fade while remaining alert to anything that suggested movement beyond the group. Even when individuals slept deeply, the structure of the group ensured that the night was rarely experienced alone. The quiet signals of other people remained close by, forming a steady pattern that supported rest within an environment that still held uncertainty. In that shared circle of breathing and warmth, sleep became not only a biological process, but also a collective experience shaped by the presence of others who were resting beneath the same dark sky. At some point in the deep past of human evolution, one of the most important changes in the experience of night began to appear: the controlled use of fire. Archaeological evidence suggests that early humans learned to maintain fire long before the development of permanent settlements. Burned bones, charcoal layers, and traces of hearths appear in several ancient sites, indicating that fire gradually became part of everyday life. Although the exact timeline is still debated among researchers, there is broad agreement that fire played a central role in shaping how humans interacted with darkness. Before fire became common, night would have been defined almost entirely by natural light from the moon, stars, or distant lightning storms. These sources could illuminate the landscape in faint and shifting ways, but they were unpredictable. A cloud passing across the moon could suddenly darken the ground, leaving only the outlines of nearby objects visible. In such conditions, the range of human vision remained extremely limited. Fire changed this experience by creating a small and steady source of light that humans could control. Even a modest fire can illuminate the ground within a few meters, revealing movement that would otherwise remain hidden in darkness. The light from flames also produces a distinctive glow that spreads upward into the air, marking the presence of a human camp from a distance. Within the circle of firelight, shapes become visible again. Faces can be recognized, tools can be handled, and the boundaries of the immediate environment become clearer. This transformation may have had a powerful psychological effect. Instead of confronting the night as an endless field of darkness, early humans could gather within a defined space where light restored some of the sensory clarity lost after sunset. Fire also produced warmth, which mattered greatly in many of the environments where early humans lived. As the air cooled after sunset, the heat from a hearth could make the difference between comfort and exposure. People naturally gathered closer to the source of warmth, reinforcing the habit of sleeping near one another. In this way, fire helped concentrate the group within a shared space during the night. The circle of warmth and light became a natural center for social activity in the evening hours before sleep. Archaeologists often find hearths positioned in locations that appear central within prehistoric camps, suggesting that fire served as a focal point for the entire group. Beyond light and warmth, fire also influenced how animals behaved around human camps. Many species instinctively avoid open flames and the unpredictable movement of firelight. The scent of smoke and the crackling of burning wood create signals that unfamiliar animals may interpret as potential danger. Although fire could not guarantee complete safety, it may have reduced the likelihood that certain animals would approach too closely. For humans resting nearby, this created a subtle shift in the relationship between the group and the surrounding environment. The fire marked a visible boundary that separated the illuminated space of the camp from the darkness beyond it. Even so, the protection offered by fire remained limited. Flames require fuel and attention. If the fire weakened during the night, its light would shrink and the surrounding darkness would gradually return. Someone in the group might occasionally wake to add wood or adjust the embers, maintaining the glow that helped define the camp's center. In this sense, fire did not remove the challenges of the night, but rather helped manage them. It provided a temporary island of light within a larger world that remained mostly unseen. Over many generations, living beside fire likely shaped how humans experienced evening and sleep. The warmth of the flames, the shifting light across nearby faces, and the steady crackle of burning wood became part of the familiar rhythm that signaled the transition from wakefulness to rest. Yet beyond that narrow circle, the wider night continued its quiet activity, reminding the sleeping mind that the darkness had never fully disappeared. Once fire became part of human life, the experience of evening slowly changed. Darkness no longer arrived as an immediate end to activity. Instead, the presence of flames extended the day into the first hours of the night. Within the circle of firelight, people could still see one another, prepare food, repair tools, or continue quiet conversations. The glow of the fire created a gentle transition between daylight and sleep rather than a sudden plunge into darkness. Over long periods of time, this shift may have shaped how humans organized the rhythm of their evenings. Anthropologists studying traditional societies often observe that fire becomes the natural gathering point after sunset. The warmth and light draw people closer together, encouraging social interaction as the outside world grows darker. Stories are told, plans for the following day are discussed, and shared experiences are remembered. These activities do more than simply pass the time. They strengthen social bonds within the group, reinforcing the cooperation that allows communities to function effectively. As the fire burns steadily and the night deepens, the group gradually grows quieter. One person may lie down first, followed by another, until the conversation fades into soft murmurs and then into silence. This gradual slowing of activity allows the body to adjust naturally to the coming of sleep. The flickering light of the fire plays an important role in this transition. Unlike the bright and constant illumination of modern electric lights, firelight shifts and moves in gentle patterns. The brightness rises and falls as flames change shape, creating shadows that slowly drift across the ground and nearby surfaces. This kind of light does not force the eyes to remain sharply focused. Instead, it produces a calm visual environment that may help the mind prepare for rest. Some researchers suggest that the warm colors and low intensity of firelight align more closely with the natural signals that the human body associates with evening. Over many generations, the presence of fire at night may have become a powerful cue that the active part of the day was ending. At the same time, the fire continued to serve practical functions. Its light revealed movement within the camp and allowed people to observe one another easily. This visibility helped maintain a sense of shared presence among the group. Even after most individuals had fallen asleep, the glowing embers could illuminate small motions near the hearth. Someone waking briefly during the night might see the faint outlines of companions resting nearby, reinforcing the feeling that the group remained together. The crackling sounds of burning wood also contributed to the sensory atmosphere of the camp. These sounds formed a steady background rhythm that blended with the breathing and movement of sleeping individuals. As the brain became accustomed to these patterns, they could fade into the background, allowing deeper sleep to occur. Yet the fire never became completely silent. The occasional pop of a burning branch or the shift of embers served as reminders that the hearth remained active. In prehistoric camps, this combination of light, warmth, and sound created a small world within the larger darkness. People resting near the fire experienced a space that felt defined and familiar, even though the surrounding landscape remained unseen. The fire did not eliminate the uncertainties of the night, but it offered a focal point around which human life could continue after sunset. Within its glow, the group could move gradually from wakefulness towards sleep, carrying with them the quiet awareness that beyond the firelight the wider night still stretched across the land. Even with the presence of fire, the night was never completely transformed into daylight. The reach of a flame remained small compared with the vast darkness surrounding a human camp. A hearth could illuminate the ground nearby, but beyond that circle the landscape quickly faded back into shadow. This contrast between the light of the fire and the darkness beyond it created a clear boundary within the environment. Inside that boundary were the familiar shapes of companions, tools, and resting places. Outside it lay a much larger world that could not be easily seen. The human mind likely became accustomed to interpreting the night through this division. The circle of firelight formed a zone where vision returned and social life continued. The flickering light revealed movement close to the camp and made it easier to recognize faces and gestures. People sitting near the fire could speak quietly, prepare food, or simply observe the glowing embers as the evening slowed. Yet every person in that space also understood that the fire did not extend very far. Beyond a short distance, darkness remained almost as complete as it had always been. In many prehistoric environments, this darkness would have felt deep and continuous. Away from artificial lighting, the night sky can appear extraordinarily vast. Stars become visible in large numbers, and the horizon often disappears into shadow. When clouds cover the moon, even nearby features may become difficult to distinguish. Early humans sitting beside a fire would have seen only a small portion of the surrounding landscape, while the rest remained hidden beyond the reach of the flames. In such settings, fire did not remove uncertainty. Instead, it created a visible center from which the unknown could be sensed. Archaeological evidence from ancient hearths suggests that these fires were often maintained carefully. Charcoal deposits and repeated burn layers indicate that people returned to the same hearth locations again and again, suggesting that the management of fire became a stable habit in daily life. Keeping a fire alive through the night required attention. Someone might wake briefly to adjust a piece of wood or stir the embers so that the flame would not disappear completely. These small actions ensured that the light and warmth of the hearth remained present until morning. They also reinforced the connection between human awareness and the fire itself. As long as the fire continued to glow, the group retained its small island of visibility within the surrounding darkness. The presence of a fire may also have influenced how humans interpreted nighttime sounds. When the immediate environment is illuminated, it becomes easier to identify the sources of nearby noises. A person can see another member of the group shifting position or observe the wind moving through nearby plants. When a sound comes from beyond the light, however, its origin may remain uncertain. This contrast between the known space inside the firelight and the unseen world outside it may have sharpened the human tendency to listen carefully to the night. Within the glow of the hearth, the brain could relax enough to allow sleep to unfold. Yet the senses still remained connected to the wider landscape through sound and faint movement beyond the edge of vision. Over many generations, living beside fire may have shaped the emotional experience of darkness. The night was no longer entirely without light, but it was never fully illuminated either. Humans slept within a small circle of warmth and familiarity, while the surrounding world continued in shadow. This balance between light and darkness allowed people to rest more comfortably than before, yet it also preserved the quiet awareness that the wider night remained present just beyond the fading reach of the flames. Even in modern homes, many people notice a quiet pattern during the night. After falling asleep, they may wake briefly at some point before morning. Sometimes the awakening is only a few seconds long. A person may shift position, glance around the room, or listen for a moment before drifting back into sleep. In the morning, these small awakenings are often forgotten, yet sleep researchers know that such moments are a normal part of the human sleep cycle. The night is not a single unbroken stretch of unconsciousness. Instead, the brain moves through repeating patterns that naturally bring the sleeper closer to wakefulness several times before morning arrives. This rhythm can be observed in sleep laboratories through the measurement of brain waves and body activity. Over the course of the night, the brain cycles between lighter and deeper stages of sleep. Deeper stages allow important restorative processes to occur, including memory consolidation and the regulation of emotional systems. Lighter stages appear regularly between these deeper phases. During these lighter moments, the sleeper can awaken more easily in response to changes in the environment. Often the awakening is brief and quiet, lasting only long enough for the brain to confirm that everything around the sleeper remains stable. From a biological perspective, this pattern may reflect a compromise shaped by the environments in which humans evolved. In a completely secure setting, a brain could remain deeply asleep for long stretches without interruption. But in the natural environments where early humans lived, The night rarely remained perfectly silent or predictable. Sounds from animals, shifting wind, or the movement of other members of the group could occasionally reach the ears of a sleeper. The presence of periodic lighter sleep phases meant that the brain had regular opportunities to check the surrounding environment without abandoning the deeper rest it needed. Anthropological observations of traditional communities often reveal similar patterns. In some hunter-gatherer societies, people do not remain asleep continuously throughout the night. Individuals may wake briefly, speak quietly to someone nearby, or adjust the fire before returning to sleep. These awakenings are usually calm and unremarkable. They are not signs of distress, but part of the normal rhythm of rest within the group. Over time, the community becomes accustomed to these quiet transitions between sleep and brief awareness. This pattern suggests that human sleep may have evolved as a flexible system rather than a rigid block of unconsciousness. The body enters deeper sleep when conditions feel stable, but it periodically returns toward lighter awareness where the environment can be sensed again. Such a system allows rest and vigilance to coexist. Instead of choosing between full alertness and complete vulnerability, the brain alternates between states that provide both recovery and occasional awareness. The presence of other people in the group likely strengthened this arrangement. If one person stirred during a lighter phase of sleep, that movement could subtly alert others nearby. The sound of someone turning or adjusting a blanket might be enough to draw brief attention before the group settled again into quiet rest. In this way, the natural cycles of human sleep combined with social proximity to create a form of shared nighttime awareness. No one needed to remain awake for the entire night, yet the group rarely became entirely disconnected from the environment. These gentle awakenings may therefore represent an ancient feature of human sleep rather than a modern disturbance. They remind us that the brain evolved within landscapes where the night was never entirely silent. Even while resting, the human mind maintained the ability to rise briefly toward wakefulness, listen to the surrounding darkness, and then return once more to sleep beneath the slowly passing hours of the night. In many modern societies, uninterrupted sleep is often considered the ideal pattern. People are encouraged to fall asleep quickly, remain unconscious through the entire night, and wake only when morning arrives. Yet historical records and anthropological observations suggest that human sleep has not always followed this continuous pattern. In earlier periods of history, particularly before the widespread use of artificial lighting, nighttime rest sometimes unfolded in two separate phases. Written descriptions from parts of Europe several centuries ago refer to what people called a first sleep, followed by a period of quiet wakefulness and then a second sleep. During the interval between these two periods of rest, individuals might sit quietly, reflect, pray, or speak softly with others before returning to sleep again. Historians believe this pattern may have been influenced by the natural length of darkness before modern lighting extended the evening hours. When night lasted many hours, the body sometimes divided sleep into two segments separated by a calm period of wakefulness. This observation does not mean that every person or culture followed exactly the same pattern. Human sleep has always shown variation depending on environment, social habits, and individual biology. Still, these historical descriptions suggest that the modern expectation of one long, uninterrupted block of sleep may not represent the only natural rhythm of the human body. Scientific studies have explored similar ideas by observing how people sleep when exposed only to natural cycles of light and darkness. In some experiments, participants living without artificial light gradually shift their sleep schedules toward patterns that include a quiet waking period during the night. During this time, individuals often report feeling calm rather than restless. The mind remains relaxed, and after a short period they return naturally to sleep. Researchers interpret these results cautiously, but they provide insight into how flexible human sleep rhythms can be when they are not shaped by strict schedules or artificial lighting. For early humans living in natural environments, nighttime likely unfolded according to similar rhythms. After evening activities around the fire slowed and the first phase of sleep began, some individuals may have awakened briefly in the deeper hours of darkness. During these quiet moments, the fire might be adjusted, a piece of wood added to the embers, or a few soft words exchanged among those who were awake. The surrounding group would remain mostly asleep, yet the camp itself would not become entirely silent. These gentle intervals of wakefulness could also serve practical purposes. A person who rose briefly might notice changes in temperature, check that children remained comfortable, or listen for sounds from the surrounding landscape. None of these actions required a formal plan or assigned roles. They emerged naturally from the rhythms of human sleep itself. Over the course of the night, different individuals might pass through such moments, creating a quiet continuity of awareness across the sleeping group. In this way, the structure of human sleep may have supported life in environments where complete disconnection from the surroundings would have been risky. Instead of demanding perfect stillness and unconsciousness for many hours, the brain allowed short returns to awareness that blended gently with deeper phases of rest. These moments were not interruptions in the true sense of the word. They were part of the larger pattern through which humans experience the night. Even today, traces of this ancient rhythm can still be felt. A person waking briefly in the middle of the night may simply be touching an old biological pattern that has existed throughout much of human history, a quiet pause in the darkness before sleep once again settles across the mind. These quiet awakenings during the night reveal something subtle about the design of the human mind. Sleep is not simply a state where the brain shuts down completely. Instead, the brain moves in and out of different levels of awareness, almost like a tide that rises and falls across the hours of darkness. During deeper phases, consciousness withdraws and the body restores itself. During lighter phases, the mind drifts closer to the surface of wakefulness, capable of responding to signals from the surrounding world. This pattern may help explain why people often wake most easily in the early morning hours, or during certain points in the night rather than at random moments. The brain appears to follow an internal rhythm that periodically lifts the sleeper toward awareness before allowing sleep to deepen again. In modern life, these awakenings are sometimes interpreted as disturbances. People may worry that waking during the night means that something is wrong with their sleep. Yet when viewed through the lens of human evolution, these moments may represent a long-standing feature of how our species has always rested. For thousands of generations, humans did not sleep in sealed buildings or silent bedrooms. The night environment continued to produce sounds, changes in temperature, and movements that occasionally reached the senses. Periodic awakenings allowed the brain to check that the surrounding world remained calm before returning once more to rest. Anthropologists observing traditional communities sometimes notice how naturally these brief awakenings fit into the rhythm of group life. A person may sit quietly for a moment beside the fading embers of the fire, listening to the distant sounds of the night. The sky above may reveal stars moving slowly across the darkness, marking the passage of time in a way that modern clocks rarely capture. After a short while, the person lies down again, and sleep returns without effort. Such moments are not filled with urgency. They are simply part of the long conversation between the human body and the natural cycles of night. These gentle returns to awareness may also strengthen the group's connection to its surroundings. When several individuals wake at different times, the camp remains loosely linked to the environment even while most people sleep. A person waking briefly might notice that the fire has grown faint and add a piece of wood to the embers. Another might hear the distant call of an animal and listen for a moment before resting again. Each small action contributes to the quiet stability of the group's nighttime life. No one needs to remain awake for hours, yet the camp never becomes completely detached from the living landscape around it. Over many generations, such patterns may have shaped the emotional tone of the night. Darkness was not experienced as a single, uninterrupted block of unconsciousness. Instead, it unfolded in layers of rest and awareness, each phase blending gently into the next. Sleep would arrive, deepen, pause briefly in quiet wakefulness, and then return again. This rhythm allowed the human body to recover while maintaining a subtle connection to the world beyond the sleeping group. In this way, the structure of human sleep may have helped people rest within environments where the night was never entirely silent or empty. Even as the body drifted into dreams, the mind remained capable of rising briefly to the surface of awareness, listening to the darkness for a moment before surrendering once more to sleep beneath the slow turning of the stars. Even while a person is asleep, the human brain does not completely stop listening. The ears continue to receive sound waves from the surrounding environment, and these signals still travel into the auditory system. What changes during sleep is not the arrival of sound, but the way the brain chooses to process it. Many sounds are quietly filtered out before they reach full awareness. Others pass through this filter and trigger a response. This selective attention allows the brain to protect sleep while still remaining sensitive to signals that might matter. Neuroscientists studying sleep have observed that the auditory system remains active throughout the night. Electrical activity in the brain shows that sounds entering the ears continue to reach parts of the brain responsible for processing auditory information. However, the brain applies a form of evaluation before allowing these signals to fully awaken the sleeper. Familiar, repetitive sounds are often treated as safe. The brain gradually learns that they belong to the normal environment of sleep. Once this recognition occurs, those sounds can fade into the background without disturbing rest. For example, a steady rhythm such as breathing from nearby companions or the soft crackle of a fire may become part of the expected soundscape of the night. These sounds are present, yet they rarely cause awakening because the brain recognizes them as predictable. Unexpected sounds are treated differently. When a new noise appears suddenly or breaks the regular pattern of the environment, the brain may respond quickly. Even during deeper stages of sleep, certain sounds can activate networks that control alertness. Heart rate may increase slightly, muscles may tense, and the brain may shift toward lighter sleep or full awakening. This process happens rapidly, often before a person becomes consciously aware of the sound that triggered it. Such responses illustrate how the brain continues to evaluate the environment even during rest. The ability to distinguish between familiar and unfamiliar sounds likely has deep evolutionary roots. In natural environments, sound often carries important information about nearby activity. A branch snapping, the movement of animals through vegetation, or a sudden change in the rhythm of the surrounding landscape can signal that something in the environment has shifted. For early humans resting in open camps or shallow shelters, hearing would have remained one of the most reliable ways to detect these changes. Vision becomes limited in darkness, but sound can travel through the night air across considerable distances. Anthropologists studying communities that still spend time outdoors at night often note how carefully people listen to the environment. Many individuals become skilled at identifying the calls of animals, the direction of wind through plants, or the difference between familiar and unfamiliar footsteps. These forms of listening are not always conscious. Instead, the brain gradually learns the normal sounds of the local landscape and reacts when something unusual appears within that pattern. This sensitivity can continue even when the body is resting. During sleep, the auditory system remains capable of detecting these irregular signals. Within a group of sleepers, this ability may create a quiet layer of protection. If a sound occurs near the edge of the camp, someone whose brain is already moving toward lighter sleep might wake and listen more carefully. That person may then alert others if necessary. In this way, the human brain maintains a subtle connection to the environment throughout the night. Sleep does not completely disconnect the senses from the outside world. Instead, it transforms them into a quieter form of awareness that listens gently to the darkness while the body restores its strength. The human brain does not treat every sound in the same way during sleep. Instead, it continuously compares new sounds with patterns it has already learned from the surrounding environment. If a sound fits within the expected rhythm of the night, the brain often allows sleep to continue. If the sound differs sharply from that rhythm, attention rises quickly even before full awakening occurs. This process happens quietly and automatically, without the sleeper making any deliberate decision. Deep within the brain, networks responsible for detecting change remain active throughout the night. These networks help the brain notice when something unexpected interrupts the normal flow of sensory information. For example, a steady background noise may fade into the mind's awareness after a short time. The brain recognizes that the sound repeats in a stable pattern and gradually stops reacting to it. But if the pattern suddenly shifts, the brain responds almost immediately. A sudden step, a sharp crack, or an unfamiliar voice can cause the nervous system to move rapidly toward wakefulness. Scientists sometimes refer to this ability as a form of environmental monitoring. The brain continues to observe the world through the senses even when consciousness is lowered by sleep. In modern homes, this system is still visible in everyday experiences. A person may sleep through the steady sound of rain on a roof, but wake quickly if the rhythm of the rain suddenly changes. A parent may sleep through ordinary background noise but awaken instantly when hearing the cry of a child. These examples show how the brain assigns meaning to certain sounds while ignoring others. The sleeping mind remains selective rather than completely inactive. In prehistoric environments, this ability to evaluate sound may have played an important role in how humans experience the night. Many natural landscapes produce constant background noise. Insects create steady vibrations in warm climates. Wind moves through grasses and tree branches. Water flows through streams or along shorelines. These sounds form a continuous acoustic environment that the brain can learn to recognize as stable. Once this familiarity develops, the sleeper can rest more deeply even while those sounds continue. At the same time, the environment occasionally produces signals that stand out from the background. The movement of a larger animal through vegetation may create irregular sounds that differ from the steady rhythm of insects or wind. The sudden call of a bird or the breaking of a branch can signal a disturbance in the landscape. Because the brain remains sensitive to these irregularities, such sounds may trigger a brief awakening or a shift toward lighter sleep. Anthropologists often note how people living close to natural environments become skilled listeners. Over time, individuals learn which sounds belong to normal nighttime activity and which suggest that something unusual is happening nearby. This skill is rarely expressed as constant alertness. Instead, it exists as a quiet familiarity with the landscape. The mind absorbs the typical sound patterns of the environment and notices when those patterns change. During sleep, traces of this ability remain active within the brain's sensory systems. Within a group of sleepers, this monitoring does not depend on a single individual. Because each person moves through sleep cycles at a slightly different pace, someone is often near a lighter stage of sleep when a sound occurs. That person may wake briefly, listen, and then return to rest if nothing unusual continues. Over the course of the night, different members of the group may pass through these moments of awareness. In this way, the sleeping group maintains a gentle connection to the environment around it. The senses are quieter than during the day, but they are never completely silent. The mind continues to listen to the night, even while the body lies still beneath the slow rhythm of sleep. Even while the human brain filters most sounds during sleep, certain signals remain especially powerful. Some noises carry emotional or social meaning that the brain has learned to recognize over many years. When these sounds appear, they can pass through the sleeping mind's protective filters more easily than ordinary background noise. This ability shows how closely sleep remains connected to memory and experience. The brain does not simply measure volume or intensity. It also interprets the meaning of a sound before deciding whether to respond. One clear example can be seen in how people respond to voices. Research on sleeping brains has shown that a person is more likely to wake when hearing their own name or a familiar voice than when hearing an unfamiliar sound of similar volume. The brain appears to maintain a special sensitivity to signals that may carry social importance. Even when consciousness fades, the mind continues to monitor these cues. This sensitivity reflects the deeply social nature of human life. For most of our evolutionary history, the voices of companions were among the most meaningful signals in the environment. A quiet call from another member of the group might signal danger, request help, or simply communicate that someone nearby had awakened. The sleeping brain therefore remained prepared to respond when these familiar patterns appeared. In a prehistoric camp, voices were not the only sounds that carried meaning. The sounds produced by the group itself formed a recognizable acoustic environment. The steady breathing of several individuals, the shifting of bodies on the ground, and the faint movements of someone adjusting a blanket created a background rhythm that the brain gradually learned to interpret as normal. As long as these patterns remained stable, the sleeper could remain at ease. But if the pattern changed unexpectedly, attention could return quickly. Imagine a camp resting beside a small fire during the deeper hours of the night. Most members of the group are asleep, and the air carries the soft sounds of breathing and the occasional crackle of embers. The brain becomes accustomed to this pattern. Now imagine that one of those familiar sounds changes. A person suddenly speaks in a tense voice, or several people shift at the same time. The sleeping brain may interpret this change as important even before full awareness returns. The body begins to wake because the sound pattern no longer matches the calm rhythm of the camp. Anthropologists sometimes describe this kind of awareness as socially tuned listening. Humans do not only listen for environmental signals such as animals or weather, they also listen for changes within their own social group. This ability allows information to spread quickly through a community, even when many members are resting. If one person notices something unusual and responds with movement or speech, others nearby may wake within moments. In this way, the group functions as a network where awareness can travel rapidly through sound alone. Over many generations, this sensitivity to meaningful signals may have shaped how human sleep interacts with the surrounding world. The brain does not simply turn away from sound when sleep begins. Instead, it continues to evaluate certain signals for their possible significance. Familiar voices, sudden movements, or shifts in the group's rhythm can all pass through the quiet filters of sleep and bring the mind back to awareness. This arrangement allows humans to rest deeply while still remaining connected to the social and environmental signals that matter most. Beneath the stillness of sleep, the listening mind continues its quiet work, attending softly to the sounds of companions and to the wider darkness that surrounds the resting camp. For most of human history, sleep did not take place inside permanent houses. The familiar image of bedrooms, walls, and closed doors is a relatively recent development in the long timeline of our species. Early humans lived in environments where shelter existed, but it was often temporary, partial, or closely connected to the surrounding landscape. Archaeological evidence from prehistoric sites suggests that people used a variety of natural spaces for rest, including rock shelters, cave entrances, and open camps arranged around hearths. These locations offered protection from rain and wind, yet they rarely formed a complete barrier between sleepers and the outside world. Rock shelters, for example, appear frequently in archaeological records across Africa, Europe, and parts of Asia. These formations often consist of overhanging stone ledges that create a natural roof, while leaving one side open to the landscape. Such spaces provide shade during the day and some protection during the night. However, they do not fully enclose the people resting inside. Sounds, smells, and moving air can still pass freely between the shelter and the surrounding environment. The people resting there would remain aware that the night continued just beyond the edge of the stone. Cave entrances offered similar advantages and limitations. In some regions, prehistoric groups used shallow caves where smoke from fires could escape easily and daylight could still reach the interior. These locations provided stronger shelter from weather and sometimes reduced the number of directions from which animals could approach. Yet even caves rarely functioned as sealed living spaces. Most sleeping areas were positioned near the entrance rather than deep inside the cave. This placement allowed fresh air and light from the fire to circulate while keeping the group connected to the outside world. In many cases, the deeper parts of caves were too dark, damp, or difficult to access for everyday living. Open camps were also common, especially in landscapes where natural rock shelters were scarce. In these settings, groups may have arranged simple sleeping areas near a central fire or chosen locations that offered natural advantages such as elevated ground or nearby water sources. Evidence from archaeological sites often includes clusters of stone tools, food remains, and hearths that suggest repeated use of certain areas as temporary camps. These camps might be occupied for days or weeks before a group moved on to follow seasonal resources. In such environments, sleep took place directly within the landscape itself. The sky remained visible overhead, and the sounds of the surrounding ecosystem continued through the night. Even when simple structures were built, they rarely resembled the solid walls of later houses. Some prehistoric shelters may have used branches, animal hides, or other natural materials arranged to reduce wind and create partial cover. Archaeologists have discovered traces of circular arrangements of bones or stones that may have supported lightweight structures in certain regions. These shelters likely helped block strong winds and provide warmth, but they were still closely connected to the outside environment. Gaps in the structure allowed smoke to escape and air to circulate, and the night remained present beyond the thin boundaries of the shelter. These forms of shelter shaped how humans experienced sleep for most of their history. Rest occurred in spaces that offered comfort and protection without fully separating people from the surrounding landscape. The ground beneath them, the air moving through the shelter, and the distant sounds of animals remained part of the environment in which sleep unfolded. In such settings, the human mind did not retreat into a completely enclosed world during the night. Instead, it rested within a space that balanced protection with openness, allowing the body to sleep while still remaining gently aware of the living world beyond the shelter. Although early humans used natural shelters when they were available, Many nights were still spent in places where protection was only partial. Human groups moved across landscapes in search of food, water, and seasonal resources, and this mobility meant that permanent structures were rarely part of everyday life. Camps were often temporary, shaped by the immediate needs of the group and the features of the surrounding terrain. When evening approached, people selected locations that offered practical advantages rather than complete enclosure. A slight rise in the ground could provide better visibility during daylight. Nearby trees or rock formations might reduce exposure to wind. Access to water and the presence of a safe place to build a fire were also important considerations. Once a location was chosen, the camp itself was usually simple. Archaeological sites often reveal clusters of hearths surrounded by tools and food remains, suggesting that people gathered around a central fire and arranged their resting places nearby. The ground may have been cleared of stones or covered with plant material to create a more comfortable surface for sleep. In colder regions, animal hides or woven materials might have been used to add warmth. Yet even with these adjustments, the camp remained closely connected to the landscape around it. The sky might still be visible above, and the sounds of the night could travel freely across the open space. This openness shaped how the human body and mind approached rest. Without walls or doors, the boundary between the camp and the surrounding world remained flexible. Movement outside the group could sometimes be heard before it was seen. A change in wind direction might carry unfamiliar scents across the ground. These subtle signals formed part of the sensory environment in which sleep occurred. The mind did not ignore them entirely, but neither did it treat every signal as a threat. Over time, people likely learned to distinguish between the ordinary patterns of the landscape and unusual changes that deserved attention. Anthropologists studying modern hunter-gatherer communities have observed similar arrangements in temporary camps. Sleeping areas are often organized around a shared fire, with individuals resting close enough to one another to hear quiet movements or voices. The group forms a small circle within the larger environment, and the fire marks the center of that circle. Outside the glow of the flames, the landscape fades gradually into darkness. Within the circle, however, the presence of other people provides a sense of familiarity that helps the body settle into sleep. These camps rarely attempt to block the night completely. Instead, they create a modest zone of stability within it. The warmth of the fire, the closeness of companions, and the chosen position of the camp work together to reduce the uncertainties of the surrounding landscape. Sleep becomes possible not because the environment has been fully controlled, but because the group has organized itself in a way that balances exposure and protection. Over thousands of generations, living in such camps likely influenced how humans interpreted nighttime space. The camp was understood as a place of shared presence, where familiar sounds and movements belonged to the group. Beyond its edges stretched a much larger world that continued to move through the darkness. The human brain adapted to this arrangement, allowing rest within the circle of the camp, while remaining capable of responding if something unusual approached from beyond it. In this way, early shelters and camps did not remove the connection between sleepers and their environment. Instead, they shaped the way that connection was experienced, creating a small island of human life within the wider landscape of the night. Even when early humans used shelters or organized camps carefully, these spaces never functioned as complete barriers against the outside world. The boundary between the sleeping group and the surrounding environment remained thin and flexible. Air moved freely through openings, carrying the scents of vegetation, soil, and animals. Sounds from the landscape could travel across the night without obstruction. A distant call, the movement of branches, or the shifting of wind through grass might reach the ears of people resting inside the camp. In this way, the shelter did not isolate the sleeper from the world. It simply softened the exposure while leaving the senses connected to the environment beyond. Archaeological evidence shows that even when prehistoric groups used caves or rock shelters, sleeping areas were often located near entrances rather than deep inside the rock. This pattern appears across many sites where hearths and tool remains have been discovered. The placement of fires near cave openings suggests that people preferred spaces where smoke could escape and fresh air could circulate. Deeper parts of caves were often too dark and difficult to navigate for everyday living. By remaining near the entrance, the group could benefit from partial protection while still maintaining awareness of the landscape outside. The night air, carrying both warmth and sound, continued to move through these spaces, This arrangement created a particular kind of nighttime environment. Inside the shelter, the fire illuminated the immediate surroundings and revealed the quiet presence of companions. Outside the shelter, darkness remained largely uninterrupted. The two spaces were not completely separate. Instead, they blended gradually, where the firelight faded into shadow. A person lying near the entrance might see the faint outlines of the landscape beyond, or watch the stars moving slowly across the sky. The sleeping area therefore existed between two worlds, the protected space of the group and the larger environment that continued to unfold through the night. Anthropologists sometimes describe such arrangements as semi-open sleeping environments. These are spaces where people receive some protection from weather, but remain closely connected to the natural conditions around them. The ground beneath the sleeper is still part of the landscape, and the air passing across the shelter carries signals from outside. In these settings, the human senses do not withdraw entirely during sleep. Instead, they remain gently engaged with the environment through sound, temperature, and subtle movement. This connection may have influenced how the human brain learned to rest. Because shelters were rarely fully sealed, the brain continued to receive information from the surrounding world throughout the night. Familiar sounds could fade into the background, while unusual signals might prompt a brief awakening. The body slept, but the senses never became completely isolated. This pattern likely reinforced the balance between rest and awareness that characterizes human sleep even today. Over long stretches of time, sleeping within such semi-open environments may have shaped the way humans understood nighttime space. Shelter created a place where the group could gather and rest, yet it did not remove them entirely from the living landscape around them. The fire, the people, and the structure of the shelter formed a center of familiarity within a much larger world that remained active beyond its edges. Within that center, the body could surrender to sleep, but the mind remained quietly aware that the surrounding night, filled with distant sounds and unseen movement, continued to exist just beyond the thin boundary of the shelter. In early human communities, the experience of night was shaped not only by the environment, but also by the presence of different generations within the group. Prehistoric groups likely included individuals of many ages living close together, adults responsible for gathering food and protection, adolescents learning the skills of the community, and young children who depended on the care of others. This mixture of ages influenced how people organized their sleeping spaces and how the group responded to the night. Children, in particular, added another layer of vulnerability to the sleeping group. Young humans are among the most dependent offspring in the animal world. Compared with many other species, human children require long periods of care before they can move independently and understand the dangers of their surroundings. During the earliest years of life, a child's ability to respond to threats is extremely limited. For this reason, children in most human societies remain close to caregivers during sleep. Anthropologists studying traditional communities frequently observe that infants and young children sleep near parents or other family members rather than in separate spaces. This pattern appears to be widespread across cultures and may reflect a very old feature of human social life. In prehistoric settings, keeping children nearby during the night likely served several purposes. First, proximity allowed adults to respond quickly if a child woke or became distressed. Young children may awaken frequently, especially in unfamiliar or uncomfortable conditions. A nearby adult could provide comfort, adjust coverings, or feed an infant if necessary. This closeness helped maintain calm within the sleeping group, preventing distress from spreading through the camp. The quiet presence of caregivers allowed children to settle back into sleep more easily. Second, the presence of children influenced how adults organized the group's sleeping arrangement. Individuals responsible for the youngest members may have chosen positions within the camp where warmth, firelight, and the protection of the group were strongest. Adults might rest in positions that placed them between children and the outer edge of the camp, forming a subtle layer of protection around the most vulnerable members of the group. While there is no direct archaeological evidence showing exactly how individuals arrange themselves during sleep, patterns observed in many traditional societies suggest that such arrangements are common when people sleep together outdoors. The presence of children may also have shaped how adults listen to the environment during the night. A caregiver resting beside a young child often remains sensitive to small changes in breathing, movement, or sound. Even during sleep, the brain can remain attuned to signals from the child nearby. Modern sleep studies have shown that parents often wake more quickly to sounds made by their own children than to other noises in the environment. This sensitivity reflects the deep biological connection between caregiver and child. In prehistoric groups, such awareness may have helped ensure that children remained safe throughout the night. More broadly, the presence of multiple generations within a camp created a layered social structure during sleep. Some individuals slept deeply, exhausted from the activities of the day. Others might wake briefly to adjust the fire or listen to the surrounding environment. Older children and adolescents who were gradually learning the rhythms of the community may have shared in these experiences as they matured. In this way, the night became part of the process through which younger members learned how to live within the group and respond to the landscape around them. Sleep was therefore not only a biological event but also a social one. The presence of children and caregivers shaped how the group organized itself in the darkness, reinforcing patterns of closeness, protection, and shared awareness that helped humans rest together beneath the long and uncertain hours of the night. The presence of children within early human groups did more than influence where people slept. It also shaped how the group responded to the night itself. Young children do not experience sleep in the same way as adults. Their sleep is often lighter and more fragmented, and they may wake more frequently during the night. For caregivers resting nearby, this pattern creates a special form of awareness. Even when adults are tired, the brain remains sensitive to small movements or sounds coming from the child. A slight shift in breathing, a quiet whimper, or a restless movement can quickly draw the caregiver back toward wakefulness. Modern sleep research has shown that adults often respond more rapidly to the sounds of their own children than to other noises. This sensitivity appears to involve emotional and neurological systems that link caregiving behavior to attention during sleep. In prehistoric environments, such responsiveness may have been especially important. A child waking in distress could signal discomfort, illness, or a disturbance in the surrounding environment. By remaining close and attentive, adults could respond quickly and restore calm within the group. This pattern of shared rest between caregivers and children likely influenced the general atmosphere of nighttime life. Because children might wake at unpredictable times, the group's sleep could rarely remain perfectly still for the entire night. Small movements or quiet voices might occur occasionally as caregivers adjusted coverings, comforted a child, or checked the warmth of the fire. These moments were usually brief and gentle, allowing most members of the group to remain asleep. Over time, such interruptions may have become part of the familiar rhythm of nighttime rest. Instead of treating every awakening as unusual, the community would have accepted these quiet moments as a normal part of life. Anthropologists studying traditional societies often observe that children remain closely integrated into the sleeping group. Infants may sleep beside parents, while older children rest nearby within the same shared space. This arrangement allows caregivers to monitor the well-being of young family members without leaving the warmth and protection of the group. It also reinforces the social bonds that connect different generations. Children grow accustomed to the sounds and rhythms of communal sleep, learning from an early age that nighttime rest occurs within the presence of others. As children grow older, their role within the sleeping group gradually changes. Older children may begin to wake and observe the night environment more consciously. They might notice the fading glow of the fire, the quiet breathing of the group, or the distant sounds of animals moving across the landscape. Through these experiences, they slowly learn how adults interpret the signals of the night. This learning does not require formal instruction. Instead, it emerges naturally from shared living within the camp. Over many generations, such patterns may have helped transmit knowledge about the environment and the rhythms of human life. Young people growing up within these groups would learn how to sleep in ways that balanced rest with awareness. They would experience the gradual transition from childhood dependence toward adult responsibility within the same nighttime spaces. In this way, sleep became part of the broader system through which communities passed knowledge and behavior from one generation to the next. The presence of children therefore shaped not only the physical arrangement of the camp, but also the emotional tone of the night. The group rested together in a state that combined care, attention, and shared familiarity. Within that circle of warmth and quiet movement, the youngest members of the community learned that sleep was never entirely separate from the presence of others. It unfolded within a living network of relationships that stretched across generations beneath the dark sky. As children grew within early human communities, their relationship with the night slowly changed. The youngest members of the group depended almost entirely on caregivers for warmth, safety, and comfort during sleep. Over time, however, children gradually became more aware of the environment around them. The sounds of the night, the glow of the fire, and the quiet movements of the group became familiar parts of their early memories. Long before children fully understood the landscape or the animals that lived within it, they were already learning the rhythms of how their community rested together after dark. Anthropologists studying traditional societies often observe that children remain close to the sleeping group for many years before eventually taking on more independent roles. This extended period of shared rest allows younger individuals to absorb patterns of behavior simply by being present. They notice when adults wake briefly to adjust the fire, when someone listens quietly to distant sounds, or when a caregiver responds to a small disturbance within the camp. None of these actions require formal explanation. Instead, children gradually understand through experience how nighttime life unfolds within the group. As they grow older, children begin to develop the same sensitivity to environmental signals that adults possess. The distant call of an animal, the shift of wind through vegetation, or the movement of someone within the camp becomes easier to recognize. These signals are not interpreted as constant danger. Rather, they form part of the broader awareness that people living close to natural environments often develop over time. Through repeated nights spent within the camp, young members of the group learn to distinguish between the ordinary sounds of the landscape and unusual disturbances that might deserve attention. This process of learning continues quietly across many years. Adolescents who once slept close to caregivers may begin resting slightly farther from the center of the group as they gain confidence and strength. They still remain within the circle of the camp, but their role gradually shifts from dependent child to contributing member of the community. In this stage of life, young people often begin participating more actively in the shared awareness that surrounds nighttime rest. A teenager waking briefly during the night might listen to the environment or check the fire before returning to sleep. Such small actions represent early steps toward the responsibilities that adulthood will eventually bring. The sleeping camp therefore functions as more than a place for physical rest. It also becomes a space where knowledge about the environment and the rhythms of life is quietly passed from one generation to the next. Children observe how adults behave during the night, and over time they adopt similar habits of awareness and calm response. This process helps maintain continuity within the group, ensuring that the knowledge needed to live within the landscape does not disappear with a single generation. In this way, the night becomes part of the long educational journey of human life. The darkness that surrounds the camp is not only something to endure but also something to understand. Young members of the community learn that sleep occurs within a living environment that continues to move and change while the body rests. Through countless nights spent beside the fire and among their companions, they gradually discover how to balance rest with awareness, just as generations before them had done beneath the same quiet sky. Across many human societies, the night has often included moments of quiet watchfulness. Even after communities developed more stable settlements, people sometimes remained attentive to the environment during the darker hours. Historical records from various cultures describe individuals who stayed awake for part of the night to observe the surroundings of a village or camp. These practices were not always formalized as strict duties, but they reflect a widespread understanding that nighttime awareness could be useful when the rest of the community was asleep. In agricultural villages that emerged thousands of years after the earliest human camps, the idea of a night watch became more visible in written sources. Some communities organized individuals to remain awake in rotation, especially when protecting stored food, livestock, or the boundaries of the settlement. These practices appear in historical accounts from many regions, including parts of Europe, Asia, and the Middle East. The details varied widely, but the basic idea remained similar. While most people slept, someone remained alert to observe the quiet hours before morning. This pattern may reflect older habits that developed long before written records existed. Even in earlier hunter-gatherer groups, the natural rhythms of sleep could create moments when individuals were awake while others rested. As described earlier, human sleep often unfolds in cycles that include brief awakenings. When these awakenings occurred within a group, they may have functioned as informal moments of observation. A person waking briefly might listen to the surrounding environment, adjust the fire, or simply remain aware for a few minutes before returning to sleep. No formal plan was necessary for this to happen. It emerged naturally from the way human sleep cycles differ from one individual to another. Anthropologists studying traditional societies sometimes observe similar patterns in modern contexts. In camps where several people sleep together, it is common for individuals to wake at different times during the night. Someone may rise quietly to tend the fire, check on children, or listen to the surrounding landscape. After a short time, that person returns to sleep and another individual may later experience a similar moment of wakefulness. Across the entire group, these small awakenings create a gentle continuity of awareness that extends throughout the night. The presence of such patterns suggests that human communities did not rely solely on complete unconsciousness during sleep. Instead, nighttime life may have included alternating periods of deep rest and brief attention to the environment. This rhythm allowed people to recover physically while maintaining a loose connection to the landscape around them. If something unusual occurred nearby, the person who happened to be awake or closest to waking could respond and alert others. Over long periods of time, the habit of nighttime awareness may have influenced how humans think about darkness more generally. Night was not simply a time when activity stopped entirely. It was a quieter phase of life when movement slowed but did not disappear. Fires still glowed softly. The breathing of the group continued, and occasional voices might break the silence. Within this atmosphere, the boundary between sleep and wakefulness remained flexible. Some individuals rested deeply while others hovered briefly at the edge of awareness. This pattern created a subtle form of protection that did not require constant vigilance. The group slept, yet the camp never fully disconnected from the environment around it. Even while most people dreamed, the community remained loosely connected to the sounds and movements of the night, carried by the quiet wakefulness of those who happened to stir beneath the fading embers of the fire. As human communities gradually became more settled, the habit of remaining attentive during the night often took on clearer forms. Villages that stored food, raised animals, or built simple structures sometimes developed informal ways of maintaining awareness after dark. The presence of stored grain, domesticated animals, and clustered homes created new reasons for people to notice what was happening around the edges of their settlements. In these settings, the quiet hours of night could carry practical importance, and communities sometimes organized individuals to remain awake for portions of the darkness. Historical accounts from many regions describe some version of this nighttime awareness. In certain villages, people took turns walking through the settlement while others slept. In others, individuals remained near central fires or gathering places where they could listen to the surrounding environment. These practices were rarely identical from one culture to another, yet they shared a similar idea. While most members of the community rested, someone remained attentive to the world beyond the sleeping houses. This habit likely grew from much older patterns of human behavior. For thousands of generations before the development of villages, humans had already experienced the night as a time when awareness and sleep blended together. The natural cycles of human rest often produced brief awakenings throughout the night. Within a group, these awakenings created moments when someone might listen quietly to the surrounding environment before returning to sleep. As settlements became more stable and populations grew larger, these informal patterns may have evolved into more deliberate forms of nighttime observation. Anthropologists sometimes point out that humans are particularly skilled at detecting changes in familiar environments. When people spend long periods living in the same place, they gradually learn the ordinary sounds and rhythms of that location. The creaking of wood, the movement of animals, the direction of wind, and the distant calls of birds all become part of the background soundscape. Once this familiarity develops, unusual sounds can stand out clearly. A sudden movement near the edge of a village, or the unexpected noise of an animal entering the settlement can quickly draw attention. This sensitivity may have made nighttime awareness easier for individuals who remained awake. Instead of scanning constantly for danger, they could simply listen for disturbances in the familiar pattern of the night. The human brain is especially good at detecting these irregularities. Even when attention is relaxed, a change in sound can trigger alertness quickly. For the person who happened to be awake during a night watch, such signals might prompt a closer look at the surroundings or a quiet call to others nearby. The existence of these nighttime roles does not mean that people lived in constant fear of the darkness. Most nights likely passed peacefully, with little more than the ordinary sounds of the landscape drifting through the settlement. Yet the simple presence of someone awake helped maintain a sense of connection between the sleeping community and the environment beyond it. If something unusual did occur, the response could begin before the entire group was awakened. Over time, these habits reinforced a cultural understanding that the night was not entirely separate from daily life. Even as people slept, the community remained linked to the landscape through those who were quietly attentive during the darker hours. The glow of a small fire, the soft footsteps of a person walking through the settlement, and the steady breathing of those who slept created a shared rhythm that connected rest with awareness. In this rhythm, the night became a time when the human community rested together, while still maintaining a gentle watch over the world that surrounded it. Even when human communities developed organized night watches, the deeper pattern of sleep and awareness did not disappear. The formal role of someone remaining awake during the night worked alongside the natural rhythms of human sleep rather than replacing them. Within a village or camp, some individuals might stay alert intentionally, while others moved through the familiar cycles of rest that included brief awakenings and moments of quiet listening. Together, these layers of awareness created a system that connected the sleeping community to the environment beyond it. Historical descriptions of nighttime life in early towns and villages often mention the quiet sounds that filled the dark hours. A watchman's footsteps might echo softly through narrow paths. A distant dog might bark and then fall silent again. The wind could move through wooden structures or across fields outside the settlement. These sounds formed the background atmosphere of the night. For those awake, they offered information about the stability of the environment. For those sleeping, they became part of the rhythm that the brain gradually learned to recognize as normal. When everything remained familiar, sleep continued without interruption. When something unusual occurred, the pattern changed. The watchman might pause to listen more carefully. A sleeper might wake briefly and notice the difference in sound. Through these subtle responses, the community maintained a gentle awareness of its surroundings, even while most people rested. Anthropologists sometimes describe this arrangement as distributed awareness. Instead of relying on a single person to detect every change, the community spreads attention across many individuals. Some remain awake intentionally, others wake naturally during lighter phases of sleep, and still others remain in deeper rest. The combination of these states creates a flexible system that can respond to events without requiring constant vigilance from everyone at once. This approach reflects the cooperative nature of human societies. Each person contributes in small ways to the overall stability of the group. The presence of distributed awareness may also explain why humans often find comfort in the quiet sounds of nighttime communities. In many places throughout history, the night was not completely silent. Footsteps, distant voices, or the faint movement of animals near the edges of a settlement reminded sleepers that they were not alone. These sounds formed a protective background that reassured the mind that others remained nearby. Complete silence, by contrast, could sometimes feel unfamiliar or unsettling, as though the ordinary rhythm of life had paused. Over long stretches of time, the habit of nighttime awareness became part of the cultural memory of many societies. Stories, traditions, and customs often acknowledged the importance of listening carefully during the night, yet these practices did not transform the night into a period of constant alertness. Most people still slept deeply for much of the darkness. What changed was the understanding that sleep and awareness could coexist within the same community. Even while individuals rested, the group as a whole remained connected to the world beyond its walls or fires. This balance between rest and watchfulness reflects a broader pattern in human history. Our species has always depended on cooperation and shared responsibility to navigate uncertain environments. The night, with its limited visibility and unfamiliar sounds, provided one of the earliest contexts in which these cooperative habits developed. While some members of the community dreamed, others listened quietly to the darkness, ensuring that the sleeping group remained gently aware of the landscape that continued to exist beyond the reach of their firelight. Over time, the relationship between humans and the night began to change. As communities grew more stable and settlements became more permanent, people gradually developed new ways to shape the environments in which they slept. Walls, roofs, and enclosed spaces slowly appeared in many parts of the world. These structures did not emerge all at once, and their forms varied widely across different regions and cultures. yet they shared a common effect. They began to place a clearer boundary between sleeping humans and the surrounding landscape. Early houses were often simple compared with modern buildings. Many were made from materials such as wood, clay, stone, or woven plant fibers. Their walls were not perfectly sealed, and the night air could still pass through small openings. Even so, these structures provided a level of protection that earlier shelters could not always offer. Wind could be reduced, rain could be kept outside, and the physical boundary between people and the environment became more visible. For the first time in human history, sleep could occur within spaces designed specifically to contain human life. Archaeological evidence shows that these changes unfolded gradually as agricultural societies expanded. Permanent villages appeared in many regions once people began cultivating crops and storing food. With these developments came the construction of dwellings that could remain in place for many years. Hearths moved indoors, and sleeping areas became more clearly defined within the household. Instead of gathering around a single fire in an open camp, families might rest inside their own structures while fires burned safely within hearths or nearby cooking areas. This transformation altered the sensory experience of night. Inside a house, the sounds of the surrounding environment became softer and more distant. Walls absorbed some of the noise produced by wind, animals, or human movement outside. The structure itself created a small interior world where the rhythm of sleep could unfold with fewer interruptions from the outside landscape. For people accustomed to open camps or semi-open shelters, this change may have felt significant. The boundary between the sleeping body and the wider environment had become thicker and more reliable. Even so, these early buildings did not eliminate the connection between humans and the night. Doors and windows remained open in many climates, and the sounds of animals or neighbours could still travel through the settlement. Firelight continued to glow within houses or nearby courtyards, maintaining a familiar presence during the darker hours. The night outside the walls remained active, even if its signals reached sleepers in a softer form than before. Anthropologists studying traditional villages often observe that nighttime life still contains elements of shared awareness. People may hear footsteps in nearby pathways, the movement of animals in fields, or the voices of neighbours passing quietly through the settlement. These sounds connect households to one another, forming a broader community even as individuals sleep within separate structures. The presence of walls, therefore, does not remove the social nature of nighttime life. It simply reorganizes the way humans experience the environment during sleep. Over generations, the development of houses gradually shifted the balance between exposure and protection that had characterized earlier forms of shelter. The sleeping body became more insulated from wind, temperature changes, and distant movement. Yet the human brain continued to carry the patterns shaped by thousands of years of sleeping in open landscapes. Even within walls, the mind still remained capable of responding to sounds, changes in light, or unfamiliar movement. The environment around sleep had changed, but the deeper rhythms of human awareness remained connected to the long history that came before the first houses were ever built. As houses became more common in human settlements, the nightly experience of rest slowly moved further indoors. Walls, roofs, and enclosed spaces created a physical separation between sleepers and the surrounding landscape that had not existed for most of human history. This separation did not appear suddenly, nor did it unfold in exactly the same way across every region. In some climates, houses remained open to allow air to circulate. In others, thicker walls provided protection against cold weather. Yet across many cultures, the general direction of change was similar. Over time, sleep became more closely associated with interior spaces built specifically for human comfort and protection. Within these structures, the sensory environment of the night gradually shifted. Wind that once moved freely across sleeping areas now passed around the outer walls of a house. Sounds from animals or distant movement became softer and more distant as they traveled through doors, windows, and building materials. The floor beneath the sleeper was no longer bare ground, but a constructed surface that separated the body from the soil and vegetation outside. These changes created a more stable environment for rest. Temperature could be moderated, and the sleeping area became less exposed to sudden environmental shifts. At the same time, human settlements were becoming denser and more socially organized. Instead of small camps moving across the landscape, villages and towns gathered many households within a shared area. Even as people slept inside their homes, the presence of neighbors remained nearby. The night was still filled with quiet signs of human life. A door might open softly in another house, footsteps might pass along a path, or animals kept by the community might move in nearby enclosures. These sounds created a new form of nighttime awareness. Instead of listening primarily to the natural landscape, sleepers often became attuned to the rhythms of the human settlement itself. Anthropologists studying traditional villages often describe how the night develops its own social rhythm. While most people rest, certain activities continue quietly. Someone may wake early to prepare for morning tasks, another may tend animals, and a few individuals may move through the settlement to check that everything remains calm. These actions rarely disturb the overall stillness of the night, yet they remind sleepers that life continues around them even while they rest. The human brain gradually learns to recognize these familiar sounds as part of the stable environment of the community. This shift illustrates how human sleep adapts to the conditions of the surrounding world. When people lived in open camps, the mind remained attentive to the sounds of wind, animals, and distant movement across the landscape. As houses and settlements developed, attention gradually adjusted to the quieter signals of human activity within the village. In both cases, the brain learned to filter familiar sounds while remaining sensitive to unusual disturbances. The basic structure of sleep did not change, but the environment to which it responded slowly evolved. Even with the protection of houses, however, the night never became entirely separate from human awareness. Doors could still open, storms could still pass across the sky, and unexpected noises could still reach the ears of a sleeper. The mind continued to maintain a gentle connection to the environment beyond the walls. Over thousands of years, human dwellings gradually increased the sense of security surrounding sleep. Yet beneath that growing comfort, the ancient patterns of listening and responsiveness remained part of the sleeping brain, quietly linking modern rest to the long history of nights spent in closer contact with the living world outside. As houses became stronger and settlements more organized, the night gradually began to feel different for human communities. Walls, doors, and roofs created layers of protection that earlier generations had never fully experienced. The sleeping body was now separated from wind, cold air, and many of the distant sounds of the landscape. This change unfolded slowly over centuries as building techniques improved and villages grew into towns. With each improvement, the environment surrounding sleep became more controlled and predictable. For the first time in the long history of our species, the human body could rest inside spaces that remained relatively stable from one night to the next. In earlier environments, sleeping places changed frequently as groups moved across the land or used temporary camps. The ground might differ from one location to another, and the surrounding sounds of animals or wind could vary depending on the season and terrain. Inside a permanent dwelling, these variations became less pronounced. The same walls surrounded the sleeper each night. The same roof overhead softened the sound of rain or wind. Familiar objects and structures created a sense of continuity that allowed the mind to relax more easily and to rest. Yet even as these protections increased, the deeper habits of the human nervous system did not vanish. The brain had evolved across thousands of generations during which sleep remained closely connected to the surrounding environment. The ability to wake quickly in response to unexpected sounds, movements, or changes in light remained part of the human biological system. Living inside houses did not remove this sensitivity. Instead, it gradually changed the kinds of signals that might trigger it. Rather than listening primarily for animals or distant movement across open ground, sleepers within settlements often responded to the sounds of human life nearby. A door opening late at night, footsteps along a pathway, or the voice of a neighbor could still draw brief attention. These signals were rarely threatening. Most of them simply reflected the quiet continuation of life within the community. Yet they demonstrated that the sleeping brain remained prepared to respond to its environment even within walls. Anthropologists studying traditional towns often note that nighttime sounds form a familiar pattern that residents quickly learn to recognize. The creak of wooden beams, the shifting of animals kept within the village, or the occasional call of someone passing through the darkness, all become part of the background rhythm of the settlement. Once these patterns are known, they fade into the background of sleep. When something unusual interrupts the pattern, attention returns quickly. In this way, the brain continues to evaluate its surroundings even in spaces designed for safety. The gradual development of houses, therefore, did not eliminate the ancient balance between rest and awareness. It simply shifted the environment in which that balance operated. Instead of sleeping in open landscapes beside a fire, humans began resting inside structures surrounded by neighbors and familiar pathways. The night outside the walls remained active, but its signals reached sleepers in quieter forms. Over time, this transformation helped reduce many of the uncertainties that once accompanied darkness. Yet the human mind still carried traces of the older world in which sleep had first evolved. Beneath the calm interior of a house, the brain continued to listen gently for changes in the environment, maintaining the same ancient connection between rest and awareness that had guided human sleep since the earliest nights of our species. Tonight, when a person lies down to sleep, the room may appear calm and secure. Walls surround the bed, the door can be closed, and the outside world feels distant. The lights are turned off, the house becomes quiet, and the body slowly prepares for rest. Yet beneath this peaceful scene, the human nervous system still carries patterns shaped across a far longer history. For most of the time our species has existed, sleep took place in environments where the boundary between the sleeper and the world outside was far thinner. Darkness was deeper, sounds travelled farther, and the landscape continued to move with the quiet activity of animals, wind, and other people. The brain that prepares for sleep tonight is the descendant of those earlier nights. Over many generations, human biology adapted to a world where sleep and awareness had to exist together. The body needed deep rest in order to restore the mind, but the environment rarely allowed complete disconnection from surrounding signals. As a result, the sleeping brain developed ways to remain gently responsive even while consciousness faded. The ears continued to receive sound, the nervous system remained capable of sudden awakening, and the cycles of sleep moved repeatedly between deeper and lighter stages throughout the night. These patterns were not accidents. They formed a balance that allowed humans to recover from the day while remaining connected to the environment that surrounded them. Modern life has changed many of the conditions that once shaped human sleep. Artificial lighting has extended the day far into the night. Houses and buildings protect sleepers from wind, rain, and many external disturbances. Cities have created environments where the sounds of human activity continue, even after midnight. In many ways, these changes have made the night far safer and more predictable than it once was. Yet the brain that enters sleep today still carries the rhythms shaped in earlier landscapes. A sudden noise in the dark can still cause immediate awakening. The mind may briefly check its surroundings before drifting back into sleep. These reactions reflect an ancient system that once helped humans rest within uncertain environments. Even the emotional atmosphere of night sometimes echoes that past. Many people notice that the darkness can bring a subtle change in perception. Familiar spaces may feel slightly different once the lights are off. Shadows appear deeper, and quiet sounds seem more noticeable. This shift does not mean that danger is present. Instead, it reveals how strongly the human mind remains connected to the conditions under which sleep first evolved. For thousands of generations, the night carried unknown elements that could not always be seen or explained. The nervous system learned to treat darkness with a gentle form of caution, allowing rest while remaining capable of awareness. Understanding this history can change how we think about sleep itself. The brief awakenings, the sensitivity to sound, and the quiet alertness of the mind during the night are not necessarily signs of disturbance. They are traces of a long relationship between human biology and the natural world. Beneath the comfort of modern homes, the ancient rhythms of human sleep continue their quiet work, reminding us that every night connects the present moment to a history that stretches back through countless generations of people resting beneath the dark sky. When we look at the modern night, it is easy to believe that sleep has always taken place in quiet rooms protected from the outside world. Beds are soft, doors can be closed, and artificial light can be switched on at any moment. In many parts of the world, the dangers that once filled the darkness have become distant or rare, yet the human mind did not evolve within these protected environments. For the vast majority of human history, sleep unfolded in landscapes where the night remained active and partly unknown. The nervous system learned to rest in conditions where darkness carried sounds, movement, and signals that could not always be interpreted immediately. Because of this long history, modern sleep still carries subtle traces of earlier environments. One of the most familiar examples is the way the brain remains sensitive to sound during the night. Even inside a quiet house, a sudden noise can cause the body to awaken almost instantly. The heart rate rises, attention returns, and the mind quickly evaluates the surroundings before allowing sleep to resume. This reaction may feel unnecessary in a safe home, but it reflects a biological system that developed when responding quickly to environmental signals could matter. The brain still performs this quiet check even when the environment no longer requires it. Another trace of this past appears in the structure of sleep itself. As discussed earlier, the human brain does not remain in one depth of sleep throughout the entire night. Instead, it moves through repeating cycles that include lighter phases where awakening becomes easier. These phases provide opportunities for the mind to briefly reconnect with the environment before returning to deeper rest. In modern settings, these moments often pass unnoticed, yet they mirror the ancient balance between rest and awareness that once helped humans sleep in open camps or near the entrances of shelters. The emotional atmosphere of night may also reflect this long evolutionary history. Many people notice that darkness can change how the mind interprets ordinary surroundings. A quiet house may feel slightly different when the lights are turned off. Small sounds may draw attention more easily, and the mind may become momentarily alert before relaxing again. These reactions are not signs that something is wrong. They are reminders that the human brain was shaped during countless nights when listening carefully to the darkness was part of ordinary life. Understanding this history can help place modern sleep within a much larger story. The bedroom, the bed, and the secure home are relatively recent additions to the human experience. Beneath these comforts lies a nervous system that developed long before such protections existed. Each night, when the body closes its eyes and allows sleep to arrive, it follows patterns that were shaped across thousands of generations. The modern environment may be safer than the landscapes where these patterns first formed, but the rhythms themselves remain deeply embedded in the human mind. In this sense, every night still carries a quiet connection to the past. When a person lies down and the lights fade, the brain begins the same ancient process that guided countless earlier humans beneath the open sky. The body rests, the senses soften, and the mind drifts towards sleep while maintaining a gentle awareness of the world beyond closed eyes. And perhaps this leads us back to the question that began this long reflection. If the human brain still listens so carefully to the night, even within the safety of modern homes, what part of our ancient past continues to echo softly in the darkness when we fall asleep? For most people today, the night has become a quiet and familiar companion. A room grows dim, the body settles into a bed, and the mind slowly drifts towards sleep. The world outside may continue moving with distant traffic, soft wind, or the quiet sounds of a neighborhood at rest. Yet compared with the long past of our species, the modern night is remarkably gentle. Walls protect us from the weather, doors close against the cold, and artificial light waits at the touch of a switch. In many ways, the dangers that once filled the darkness have become distant memories within the structure of modern life. But the human body does not forget the environments in which it evolved. The brain that prepares for sleep tonight carries the inheritance of thousands of generations who rested in a very different world. For most of human history, sleep arrived in landscapes that could not be fully controlled. Darkness concealed movement beyond the reach of vision. Animals continued their lives through the night. The wind carried unfamiliar sounds across open ground. In those environments, the human nervous system developed a careful balance. It learned to allow deep rest while preserving the ability to awaken quickly if the environment changed. That balance still lives quietly within the mind today. The cycles of sleep that move between deeper and lighter stages, the way the brain continues to listen to sound, and the brief awakenings that sometimes occur during the night are all part of that ancient design. These features are not flaws in the human body. They are traces of a long partnership between our species and the world that surrounded it. Understanding this history can change how we think about the night itself. Darkness is not simply the absence of light. For most of human existence, it was a living part of the environment, one that required awareness, cooperation, and trust within the community. People rested beside one another, gathered around fires, and listened quietly to the rhythms of the landscape beyond their camps. Sleep was not isolation, it was a shared experience within the presence of others and within the larger world of nature. Today, We often sleep alone in enclosed spaces that feel far removed from those earlier environments. Yet the ancient patterns remain inside us. When a small sound draws our attention in the night, or when the mind briefly wakes before returning to sleep, the body is simply following instincts that once helped our ancestors survive the darkness. These instincts remind us that sleep has never been only about rest. It has also been about connection to the people beside us, to the environment around us, and to the long history that shaped the human mind. Perhaps this is the quiet lesson hidden within the story of human sleep. For thousands of generations, our ancestors learned how to rest even in uncertain conditions. They did not wait for perfect safety before closing their eyes. Instead, they trusted the presence of their community, the warmth of the fire, and the resilience of the human body itself. And so each night, when we lie down and allow sleep to arrive, we participate in a tradition far older than any city or house. Beneath the calm surface of modern life, the ancient rhythm continues humans resting beneath the night, listening softly to the world beyond their dreams.